A confirmation regarding the audio, please, guys. If you are able to hear me out, kindly confirm the same. Thank you. Okay. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep IAS. Welcome to another session of Oceanography, where we shall be continuing from where we left off yesterday. Now, here, what is it that we looked at yesterday? So yesterday we tried to understand the characteristics and the features of ocean temperature. How is it that temperature ends up varying both horizontally as well as vertically in terms of depth? We looked at the fact that at the ocean bottom, the temperature is largely consistent around 4 degrees Celsius. And the surface variations in temperature are basically attributed to the factors of latitudinal extent, unequal distribution of land and water, maybe a particular water body is surrounded by land from all sides, and all these factors, including the prevailing wind patterns, including the portion of ocean currents, all of them influence oceanic temperature. Then, after that, we looked at salinity and the changes in oceanic salinity. How is it that oceanic salinity ends up varying not only from one region to another in the terms of horizontal aspect, but also vertical aspect? When we say a horizontal change in salinity, we basically mean that the influences of evaporation, precipitation, the influx of river water, as well as the freezing and melting of glaciers, how is it that they end up influencing the oceanic salinity which is experienced? We also looked at the concept of halocline. And then furthermore, we understood the aspect of how is it that salinity varies as you move to the depth. There also we saw, just like the case of temperature, the salinity at the depth is significantly similar, roughly around 35 parts per thousand. Now, then we looked at that how the differences in temperature and salinity conditions, they end up inducing a kind of a circulation within the various different parts of the oceans, whereby oceanic water at lower latitudes, they tend to expand a bit under the circumstances of heating, and once they expand, that is when the oceanic waters, they tend to move towards the polar region, where the water is slightly compressed or contracted due to very cold conditions, and that induces a kind of a thermohaline circulation. Then we looked at what are waves, what are tides, what are the factors which influence the tides, and now we have come across the ocean currents. Now, we had done the basic introduction of ocean currents, that what do we understand by ocean currents. So today, what is it that we are going to study? We are going to study about the various different forces which end up influencing the ocean currents that we experience, the different types of ocean currents which are in existence in different parts of the world, different oceans, what kind of ocean currents do they experience, and we will take a look at the various different circulations which happen across the globe, whereby the waters of all the various different oceans end up mixing with each other. That is the global conveyor belt. So these basic concepts we will be taking a look at, and after that, the coral reefs, before we enter into the portion of Indian geography. Okay, so how many of you, by the way, managed to revise the sessions of oceanography till now? How many of you have managed to revise? Good. regardless of from wherever you have revised, even if you have revised from NCRT or from the basic book or from the additional reading materials or from the PPTs, anywhere from where you have revised, the crux is that you should be revising. That is what will make the next portions very digestible. And having said that, tomorrow you will have the questions uploaded, the objective questions, 20 objective questions, and a set of 5 subjective questions from the portions that we have covered in this week. So kindly try to create an answer out of it, write an answer, put an effort. It is not going to be the ideal answer. It is not going to be the best answer that you can write. You will improve, and that is a fact. The answer that you write today, that is only going to be a stepping stone of the answers that you eventually are able to write. But you need to start somewhere. So that is why I would urge all of you to please go for the test that we shall be uploading tomorrow, both in the case of objective questions as well as in the subjective questions. Okay? Now, here we start with the forces which contribute to ocean currents. That is, when we do know that oceanic waters end up moving from one area to another, that is, in a definite path, in a definite direction, and carrying a definite volume of water from point A to point B. That is what is an ocean current. And it is regular in flow. It is not that if that today the water is flowing and maybe again water will flow after 10 years or 5 years. No, it is a regular flow. In fact, in some of the ocean currents like the Gulf Stream, you have close to around billions of gallons of water. They are transferred every day. They end up moving on a daily basis. So that is where you have to understand that what these ocean currents are, they are nothing but a primary movement of oceanic water in a certain set direction, in a certain set path, and also carrying a certain volume. So you have certain kinds of forces which will initiate this. So let us take a look at that. Now, before that, let me ask you one basic question out of it, that when you think about an oceanic water, and it is absolutely okay to be incorrect here because we have not read this. So when you consider the oceanic water which has got a depth of, let's say, 5 kilometers. Now, if I say that oceanic water ends up moving in a certain direction, that is what constitutes an ocean current. What do you think would be the scenario? If you imagine the oceans, what do you think would be the scenario? Would that motion be observed across this 5-kilometer depth, or would it be restricted into upper portion of the oceans? So this oceanic current, would it be present all through the ocean to the very depth, or would it be present only in the upper surface? Very good. So most of you are correct. It is something which is prevalent in the upper surface. You have other circulations which are also present at the depth, but ocean currents, they are mostly restricted, majorly restricted to the upper surface only. Now, having said that, let us take a look at the different types of forces. Now, starting with the first major force or the first major initiator of this ocean current is the solar heating which is received by the oceans, especially in the lower latitudes, that is around the equatorial areas. Now, in the lower latitudes, we know that the amount of solar energy which is received is very high, enormously high, isn't it? In the lower latitudes, the amount of solar energy received is extraordinarily high, due to which what will happen? The heating will be very significant. Now, due to that increased amount of heating, you have the factor that water ends up significantly expanding, and there water gains close to around a height of 8 centimeter around the region of the lower latitudes as compared to the higher latitudes. So what it translates into, if you consider the various different latitudes, that means water at the region around lower latitude, that is higher, slightly higher as compared to the water which is present at the lower latitudes. Now, this height difference is created. Why? Because of heating. Increased heating. Increased heating leads to what? Increased heating leads to expansion. Now here, this height difference which is created, whenever you have water or any fluid which is subjected to a height difference, that fluid or that water tends to flow from a greater height to a lower height, isn't it? If you keep water at at the same levels, water will not exhibit a flow. But as soon as you indicate a kind of a height difference, water will immediately initiate a kind of a flow mechanism. So here also, water will initiate a flow towards the higher latitudes, right? So that is the prime factor. If that heating would not be received, that expansion would not have happened. And in the case of lack of that expansion, water movement would not have been observed at all. So here, heating by solar energy causes the water to expand, which results in about 8 centimeter higher water level at the region of equator compared to the mid latitudes and the higher latitudes. This small gradient is enough to initiate a kind of a flow. Now it is enough to initiate a kind of a flow. But flow in what direction? There needs to be some other guiding force which will direct the flow, which will channelize the flow. Because we have seen that ocean current does not mean that entire Atlantic Ocean moves to the polar region, from lower latitude to the polar region, or from to the southern hemisphere. It is not like that. Ocean currents, they exhibit a kind of a pattern, a kind of a direction. So even after expansion, you do need the help of other forces to channelize that kind of a flow. And that channelization is provided by the wind energy. So wind, when we talk about wind, which kinds of winds are we talking about here? We are talking about the permanent wind systems. So here we talk about the existent permanent winds. Amongst the permanent wind systems, which are the winds which initiate the movement? You have the trade winds. Then we have the westerlies. We also have the polar easterlies. Okay, so it causes the surface water to move, and along with that, it provides a definite direction, to the flowing water. Whether the water will be moving from east to west, west to east, then maybe south to north, north to south, all of this, in many of the cases, is channelized by the wind movement in that region. Now, other than the wind, you also have the Coriolis force. Coriolis force is always at play. And we have seen that any object which moves independently, like you have the aeroplanes, the air movement, any kind of such movement, they experience a kind of a bending due to rotation of the planet. Similarly, ocean waters also, when they end up moving, especially in the upper portions of the oceans, they will also start acting like independent moving bodies. And they will also be influenced by the rotation of the earth. As a result of that, any oceanic current moving in the northern hemisphere will experience a bending to the right, bending to the right, and to the left in the southern hemisphere. So that is where the role of Coriolis force comes in. So that is why what you will observe is something very simple here. Let's suppose this is the planet. Let us suppose this is the region of equator. equator. Now here, suppose oceanic water tends to move like this. After some time, it will be bending to the right due to Coriolis force. So it will bend to the right. After some time, as the water is moving, it will again bend to the right. After some time, again this process will continue. And that is why you will observe that oceanic circulation in the northern hemisphere is mostly in the clockwise direction. Okay, so oceanic circulation in northern hemisphere is going to be what? Clockwise direction in most of the cases. Indian Ocean is a bit of an anomaly. Northern Indian Ocean is a bit of an anomaly, and we'll take a look at that, why it is and what is the anomaly that we are referring to. So it tends to move in a clockwise direction. Clockwise direction. Whereas when we talk about the southern hemisphere, in the case of southern hemisphere, the water will be bending to the left due to the effect of the Coriolis force. So they will be bending to the left, again to the left. And that is why across all the oceans in the southern hemisphere, the ocean currents will observe a kind of an anti-clockwise circulation. So that is where you will observe oceanic circulation in southern hemisphere is mostly anti-clockwise. And this is true for all the circulations in the southern hemisphere. Here we have one exception which we will take a look at it, except northern Indian Ocean. That is the only exception that you have here. Except in the case of northern Indian Ocean, you have a kind of a permanent circulation observed, at least a circulation pattern and a circulation direction that is observed across these two oceans. Now, these are basically one of the major forces, few of the major forces which attribute to the movement. But then movement is also facilitated and impacted by certain other factors and other forces. Like what? Like the shape of the coastline. When we talk about oceanic circulation, we have to understand that oceans are surrounded by continents from different sides. So if, let's suppose, the ocean water comes here and there's a coastline here, the coastline will divert the oceanic water accordingly, isn't it? So shape of the coastline is again a major factor influencing the movement of and the circulation of water. So here, shape of the coastline influences the direction. Why not in the northern Indian Ocean? I have repeated 5 times. We will come to it. Have patience. We will come to the features of northern Indian Ocean. We'll come to the oceanic circulation of northern Indian Ocean and we will explain it. Okay, so don't worry. I'm not going to leave you without explaining any of these facts. So please kindly don't get impatient. So that is what influences the direction of the flow which we have. Now here you can see that oceanic waters, they come here. Here you will observe that around the Caribbean islands in this area, these Caribbean islands, they will offer a kind of an immediate obstruction to the flow of water. Now when they offer an immediate obstruction, what will happen to the ocean current or the ocean water? Will it start climbing over the islands? No. It will basically break or diverge into 2 different components. So you will observe that one ocean current comes from here, other ocean current comes from here. Again, Gulf of Mexico, oceanic water enters here. And after circulating through the Gulf of Mexico, it eventually comes out in the region of the Atlantic. So if the coastline would not have been like this, the water would not be distributed in such a manner. So that is where the shape of the coast is very instrumental. For example, you can give the case of the Western Atlantic Ocean around the region of Caribbean islands and around the region of Gulf of Mexico. Then here also, if you take a look at the Northern Atlantic, in the Northern Atlantic as well, you will observe that because of the various different features of the landmass that you have, that means the oceanic circulation and the oceanic water, some part of it will go here, some part of it will go here. Wherever they will find the direction, some part will go like this. Eventually, you also have some part which enters the Mediterranean. So wherever they find indentures in the coastline or any kind of inlet across the coastline, the oceanic circulation will be impacted accordingly. Now, you also have another minor factor which influences the flow. And that minor factor is the bottom relief. Bottom relief in the oceans. Now, which bottom relief are we talking about here? After all, the oceanic bottom has got many different types of topographical features. So which feature are we referring to here? So here we refer to the existence of, in certain cases, even seamounts which are very close to the sea level. If let's suppose, excuse me, if let's suppose this is the level of water, this is the base. If you have a seamount like this, very close to the surface level of water, then if there is a circulation happening, that will also be impacted. But these seamounts are present in isolated form here and there, and that is why they don't have a greater effect. The one bottom relief which has got a significant effect is the presence of mid-oceanic ridges. Mid-oceanic ridges. Now, mid-oceanic ridges, they are like a continuous hill-like structure in the middle of the ocean. In fact, most of the mid-oceanic ridges across the world, they are connected. And overall, all these mid-oceanic ridges, can you estimate the length of mid-oceanic ridges that we have in the oceans, the interconnected mid-oceanic ridges that we have across the oceans? Can you take a guess? What would be the total length of all these mid-oceanic ridges taken together? Well, Abhishek, that is not a guess, but it is correct. Very good. It is close to around 65 to 67,000 kilometers in length. So overall, it forms one of the largest ranges across the planet, just that it is underneath the ocean. What is the extent of the Himalayas? The mighty Himalayas, the lofty Himalayas that we talk about, they are basically only around 2,500 kilometers. So put it into perspective, these mid-oceanic ridges, they extend for close to around 64,000 kilometers across the planet. So obviously they are significant. Now these mid-oceanic ridges, when an oceanic water comes over it and an oceanic circulation comes over it, imagine, obviously these mid-oceanic ridges won't be absolutely plain. These will have corrugated features. These will have a kind of a divided feature from where volcanic eruption would be coming out from different places. So imagine this is the mid-oceanic ridge in any particular area, which has got various different indentures, just like the fingers here show. Now imagine if the oceanic current is coming here from this direction and it encounters this mid-oceanic ridge. What will happen? All these indentures will start acting like separate channels, and thereby they will be diverting and deviating the ocean water. So here, oftentimes, oceanic waters or ocean currents, when they encounter the ridges, they get bifurcated or trifurcated. For example, here I will not take you very far. The same image, if I pull your attention to the same image. Now, we have all studied in significantly greater detail the existence of the mid-Atlantic ridge, the oceanic ridge which exists across the region of the Atlantic. That is what we have looked at. Now, this mid-Atlantic ridge extends all the way from Iceland in the north and it moves into the southern hemisphere as well, isn't it? That is where the Atlantic Ocean is widening over a period of time and North America is being pushed away from Europe, South America is being pushed away from Africa. We have looked at that in significant detail. Now, these ridges in different parts, they are named after the individuals who have found it or the regional aspect of that area. Here, a part of the mid-Atlantic ridge in this region, this is what is the Wyville-Thomson Ridge. It is a part of the mid-Atlantic ridge. So here, for example, the Wyville-Thomson Ridge which is a part of mid-Atlantic ridge. Now, this Wyville-Thomson Ridge, when you have the ocean currents of the northern Atlantic Ocean, when they hit that area, they immediately start dividing. So, Wyville-Thomson Ridge leads to the trifurcation of the oceanic currents into different parts. So, it divides the ocean currents into different parts and into different portions. Okay, so that is what you have as the impact of the bottom relief. Example you can always cite. Example is the Wyville-Thomson Ridge. By the way, it is not important for general studies to be knowing the different subdivisions of these ridges. It is only essential for your optional area. For general studies, you don't need to know the details of it. So just look at this as an example point, because UPSC tends to ask this question again and again in the subjective part. So there you need to know just as an example, but the other ridges you don't need to take a particular attention for. So example, Wyville-Thomson Ridge. Okay, so that is where you have the impact which is experienced in the case of ocean currents and the different ocean currents. So if a question is asked that what are the forces which influence the movement of oceanic currents, so there you have to count out each of these forces and you have to elaborate with the help of suitable examples as well. Okay, so that is something which is absolutely essential. That needs to be counted again. Okay, so what are the various different forces? Heating by the sun leads to expansion, initiates a movement, carried by the wind, that provides a channelization, a definite pattern. Then Coriolis force provides a kind of a bending which is required. Shape of the coastline further influences the direction of flow. Then when they encounter the ocean bottom relief, depending upon the type of relief, depending upon whether the relief is large enough or not, they can get bifurcated, trifurcated, or divided into various parts based upon the characteristics of the relief feature. So these are the various forces and factors which influence the ocean currents. Now let us analyze few of the properties of the ocean currents before finally jumping into the understanding of what the ocean currents are and what are the various types of currents in different oceans. Okay. Influence of Coriolis force is very simple, Amit. Water moving in the northern hemisphere will be bending towards the right, oceanic water. Please don't try to connect it with, but my tap water is flowing without bending to the right. We are talking about free movement, and that free movement observed in the ocean. So, in the northern hemisphere, it will always bend to the right. In the southern hemisphere, it will always bend to the left. Okay. Now, then after that, no, Srini, that is not correct. We'll take a look at it again and you will understand it. So, and again, I told you, please don't try to relate it with the river movement. River movement will never experience Coriolis force because rivers are very small. They are not so wide to have a circulation within themselves. Wherever you have large enough areas where you can have an independent circulation, only in those areas Coriolis force will be impacting. Okay, so Ganga, Brahmaputra, all these examples that you have, please keep it inside your pocket. In these areas, you won't find any Coriolis source, neither in lakes nor in ponds. Before you ask, neither in your water tanks, neither in your water taps, in nowhere else. Coriolis force will be acting in large independent movement. That is why air movement is impacted. That is why you have airplane movement which is impacted. That is why ocean currents are impacted. Now here, when we take a look at the characteristics of these currents, what are the characteristics exhibited by these currents? So here, the currents which are influenced by all these factors, they will be mostly a surface phenomena. The wind pattern, the expansion, the shape of the coastline, everything is more or less a surface phenomena. So here, let's suppose you have oceanic water which is present. And this is the depth of the ocean. Let us suppose the depth of 5 kilometers. Right? Now, in this case, initially the wind, etc., they will be channelizing and carrying some amount of water, maybe by some force. Now, that water on the surface, which is being attracted by the wind, it will also exert a pull on the lower level, but slightly to the lesser extent. That will extend a pull to the even lower level, but again to a lesser extent. This will continue. So that is why you will observe that the ocean currents, they are strongest at the surface. The currents are strongest at the surface and may attain a speed of close to around 5 knots. What is knot, by the way? How many of us are aware of what do we mean by a knot? Good. It is generally an indicator of speed. Okay. So when we talk about a knot, it is generally an indicator of speed that you have. And it is from here that when we say that the movement is at a rate of 1 knot, it represents close to around 1.8 kilometer per hour as the rate of movement. So the origin of this knot system goes back a long time, when in order to measure the distances, you had large ships carrying very large ropes and they would have knots at a particular distance. So that would be used to measure distance from point A to point B, and accordingly, knot is still something which is used in even in aviation industry. When you talk about the airline speed, you will always observe that airline speed primarily is depicted in knots and then it is converted into kilometer per hour. So that is what knot is. So here at the surface, the speed might be close to around 5 knots, whereas at depth, the speed might reduce to only around 0.5 knots. So that is where here you will have the fastest speed, and here you will have the slowest speed. So at depth, these ocean currents, they have a speed of around 0.5 knots, reducing furthermore as you go to the greater depth as well. Then ocean currents are also basically classified based upon the level at which they are moving, the level at which they are flowing. So accordingly, we have the classification as surface currents, that is the ocean currents which are restricted to the surface, and the ocean currents which blow or which flow at the lower levels. So here you have the surface currents, all the ocean currents that we are going to study, that is included within the surface currents, right? So this surface currents constitutes only around 10% of the water. That is only from the sea level to a depth of only 400 meters. Only to that extent is the water influenced to move in a certain direction due to the factors of wind, sun, Coriolis force, etc. Okay, at the bottom, where you have a consistent temperature and salinity conditions, there the movement is something which is influenced by thermohaline factors in many of the cases. So here you also have deep water currents, and these deep water currents, they play a significant role, as we studied yesterday. For what? For distribution of heat, and also for distribution of nutrients from one part of the ocean to the other part of the ocean. So they move around the ocean basin due to variation in density and gravity. Gravitational pull will pull in the heavier water which has got greater density, and the lighter which has got lower density will tend to rise up. So mostly in deep water currents, mostly thermohaline circulation is observed. Mostly you have thermohaline circulation which is observed. And always remember the utility of thermohaline circulations: distribution of heat, distribution of nutrients. Very, very important for survivability of all those benthic species which live at the ocean bottom. And they are basically dependent on these kinds of circulations to bring them nutrients from various other parts. So this is based upon the depth. Now, ocean currents are also divided based upon the aspect of temperature. So accordingly, based on temperature, you have the division of ocean currents into cold currents as well as warm currents. So this is divided into cold and warm. Think about it, just like we were looking at the advection process. How we looked at the advection process of the movement of wind, where horizontal movement of wind, that also is important for regulation of climate and temperature, where we saw that when you have hotter wind coming into a colder area, that will warm up the region. Colder wind coming into a hotter area, that will cool down a region. Similarly, cold ocean currents and warm ocean currents, they are basically categorized based upon the temperature that they experience. Now, what is the temperature range? When is it that we refer to as an ocean current to be a warm current? And when is it that we refer an ocean current to be a cold current? Is there an absolute kind of a ceiling that, okay, water above 15 degrees Celsius will be warm, water below 15 degrees Celsius will be cold? Is there a ceiling like that? No. It is always relative. Okay? Both of these are always relative. Relative to the temperature observed in the water at same latitudes. What does that mean? So basically, again, let us think about an analogy. Let us take an example here to understand this. Suppose, let us say, we consider the case of Pacific Ocean. Let us suppose this is your equator. Now here, you have water which is moving I hope we understand the broader temperature experienced in various different latitudes, but let us be more precise. Let's say in the higher latitudes, the temperature of water closer to Alaska, let's say closer to Alaska, the temperature normally is around 7 degrees Celsius, right? Temperature of water. Okay. Let's suppose the temperature closer to the equator, that is the tropical waters, temperature is 22 degrees Celsius. Okay. Now here, if I assume that the ocean current which is coming here, this is at a temperature of 15 degrees Celsius. So when this ocean current goes into the region of Alaska, there the water is 15 degrees Celsius. But then in that region, the surrounding water is at what temperature? 7 degrees Celsius. So whether this will be considered as a cold current or a warm current? It will be considered as a warm current. So this will be a warm current. Now the same water, the same 15 degrees Celsius water, let's say it also goes at around 22 degrees Celsius region. So the surrounding water temperature is 22 degrees Celsius and this is at 15 degree. So this will be very cold in comparison. So this will be a part of cold current. So what can we extract from this? What we basically end up extracting from this is the fact that the same ocean current can behave as a warm current in the higher latitudes, and the same ocean current, when it comes to the lower latitudes, it can start behaving as a cold ocean current, because what we need to consider is not the absolute temperature of the current, but the relative temperature of the waters in the nearby region. That is what determines and that is what controls the categorization into cold and warm ocean current. Okay. So here, that is what we have as the characterization based on temperature. So cold currents, they bring cold water into the warm water areas, just like the process of advection, where you have cold winds brought into warm areas. So that is the same process here. Now, these cold currents are usually to be found on the west coast of the continents in the low and middle latitudes. West coast of the continent. Why? So here, if you think about it, again, let's suppose we consider lower latitude. And here, this is, let's say, equator. And here you have a continental landmass. Now, this will be east coast. And this will be your west coast. I hope east and west is not something where you will be confused anymore. So here, what is experienced in the west coast? As you have wind movement which is observed, in general, that is how the trade winds will move, isn't it? Now let us consider the region A, that is the west coast. Let us represent west coast by A, and let us represent east coast by B. Now here, these are the trade winds which move here. But here, if you take a look at it, both of these coastlines will behave differently due to the same winds. When we talk about the west coast, what surface phenomena will be experienced here? Upwelling or downwelling? What do you think? Here, will we observe upwelling or downwelling? Beautiful. Here we will be observing upwelling, because as the winds are moving away, they will carry the surface water along with them, bringing the subsurface water to the top. and subsurface water is cooler and colder than the surface water. So here in the west coast, you have colder waters, due to upwelling. Colder waters due to the upwelling which goes on. And these colder waters, if there is a circulation in this region, obviously you will have cold current. Now, in the case of east coast that is B, the same wind is moving, but here, will you observe upwelling or downwelling? What do you think? Pretty clear? Here you will experience downwelling. So here you have warmer waters due to downwelling. Downwelling leading to warmer waters. That is why you come across a situation where mostly across the west coast in the lower and the middle latitudes, you will observe the presence of cold ocean currents. Whereas across the east coast, you'll find the existence of warm ocean currents. So warm ocean currents, they are relatively warm, right? They are relatively warm. So mostly, where do you think that warm waters will be found? Whenever you have water moving from lower latitude to higher latitude, that will mostly be bringing warmer waters, isn't it? So mostly bring waters from lower latitude to higher latitudes. Because at lower latitudes you will have warmer water, at higher latitudes comparatively colder waters. So whenever water is coming from lower latitude to higher latitude, generally you will find the presence of warm ocean current, and in the case of cold current, generally you will find waters brought from higher latitude to lower latitude. Okay, water brought from higher latitude area to a lower latitude region, that will always bring in. So from higher latitude, generally you have water bodies which are colder as compared to the region around equator. So if water is brought from higher latitude to lower latitude, it will be comparatively a cold current, isn't it? So that is where you have the warm currents bring warm water into cold water areas and are usually observed on the east coast of the continent in the low and middle latitudes. Due to what? Due to downwelling. So this is observed when? In the low and middle latitudes. Is it something which is observed in higher latitudes? No. It is observed mostly in the trade wind zone, where you have the existence of the lower and middle latitudes. It is there that you have the upwelling and downwelling feature created on the east and the west coast, right? Now, after this, we move on to the different types of ocean currents and oceanic circulation observed in the Atlantic Ocean, observed in the Pacific Ocean, and also observed in the Indian Ocean. Even though if you understand one of them, either one of them, that is Atlantic Ocean, if you understand, you will be able to understand almost all of them, because the fundamentals followed are very simple and are very similar. The fundamentals are not different. Okay, and the written portion for all of these ocean currents you will find to be present in the additional reading materials as well. So you don't need to be jotting down that what ocean currents, what are the properties that they have. As of now, spend all your energy in just observing and understanding how these ocean currents will circulate and what are the features that they exhibit. Okay, before that, let us take a couple of questions first. Okay, Pratyaksh, you have a question that waters on west coast is cold, so current coming will feel like warm. No, the current which does flow along with those waters, that is generally colder. It is not as if there is presence of cold water and then a current comes. Think of those cold waters as being a part of the circulation. Okay, Pratyaksh. Jasmeet, can one of the reasons be the clockwise and anti-clockwise circulation due to which cold water gets accumulated? So if that would have been the case, Jasmeet, then why only lower and mid latitudes? Think about it. Why only lower and mid latitude? Why not higher latitudes as well? So lower and mid latitudes is talked about because of the presence of the trade winds. Okay. Why most of the trenches are in the region of the Pacific Ocean, Karthik? Because that is where significant amount of subduction of the oceanic crust is happening. As the Pacific floor is getting subducted from all sides, that is why you have trenches, volcanic eruptions, and the Pacific Ring of Fire as well. High salinity in tropics is just because of high evaporation and low rainfall, XY, yes. Devansh, correct. And Pushpendra, my friends are taking coaching and they are learning the southeast and the northeast points of all continents. So my question is, are these relevant for us? Pushpendra, rather than asking this question from me, do one thing. Whenever you have this doubt in any subject, let alone this subject, and this is something that I have been telling from day one, that one of the characteristics which defines a UPSC candidate is the fear of missing out. And that is the fear that you will perpetually have till the day you enter the exam hall, until the day you clear the exam. That friend is reading that, I have not read that, so that is why I'll not clear the exam. Do one thing. This doubt is very relevant and it will be present. Whenever you have such doubts, always open up the previous year questions. When you take a look at the previous year question, find out whether this question has been asked at all, which is the northernmost point of a continent, southernmost point of a continent. You'll find that this is a question which has not been asked in UPSC for the past 25 years, right? In the meanwhile, UPSC has changed its pattern multiple times, but UPSC has not asked these questions. So always I would suggest that whenever you have these doubts that whether this is important or not, regardless of whatever I say, regardless of whatever anybody says, use your own judgment at play, because it is your journey, because it is going to be your exam. Nobody else is going to be held responsible at that point of time. Analyze based on the PYQs. That whether this is relevant or not, I hope you get the understanding now. Okay. Pranay, speed of ocean currents due to difference in pressure. Difference in atmospheric pressure, Pranay, if you are talking about. So that does influence the speed in the localized area, but in a very small area. It does not initiate a sustained decrease or increase in speed. And Yaram Sethi, I have on Odisha at some villages. At some village within half an hour, around 5,000 plus thunderstorms and lightnings recorded. It is possible. It is absolutely possible. Thunderstorms and lightnings are always possible. See, when you have a volcanic eruption, I'm just giving you an example. Whenever you have a volcanic eruption, the huge amount of smoke and cloud that is released. Because you have so much of materials which rub against each other, you have hundreds and thousands and millions of of thunderstorms which happen within the cloud. So it can always happen. Whenever you have intense convection, it can always lead to violent thunderstorms. And what is the device used to record this? Satellite data gives us the information of that. And any economic impact will come to it. Example of cold and warm current, Satya will come to it. Don't worry. Any doubt that you have till now? Harshita, here the water experiences upwelling in the west coast but the trade winds is coming from east. How is it that the west coast experiences upwelling? Fair enough. Okay. Think about it. This is a very basic question. Think about it. When is it that you have upwelling? If you think about upwelling and downwelling, when is it that you experience upwelling? If this is the water, when is it that you will experience upwelling? Whenever you have offshore winds, the surface water will be carried away and the subsurface water will emerge to the surface. That is when you will experience upwelling. And when is it that you experience downwelling? When you have a reversal of the wind direction. When you have onshore winds that will pile up the warm waters. Okay. I hope that portion is clear. Right? Now think about it. Why East Coast and West Coast? If the trade winds are moving like this, won't they be able to reach the West Coast, the trade winds? If the trade winds are moving like this across Africa, they will be observed across the West Coast as well. So across the West Coast, are these winds onshore or offshore? So these winds are offshore. So here, what do you experience? Here, what is it that you experience? You experience a kind of an upwelling in action. And what do you experience here? You experience downwelling because it is onshore wind. So it is not as if because that wind has caused downwelling, now that wind is disqualified for running again and that wind won't be allowed to go to the west coast. It is not like that. The same wind will be moving over the continents and moving across the west coast as well. Okay? I hope that is clear. Okay? Mango showers, which is good for production, but it also affected by hailstorms in this area, cumulonimbus cloud formation. Pranay, your question is not clear. Yesterday on newspaper, mango production affected. See, mango showers, where are they experienced? In which part of the country do we experience mango showers? Let me know. Is it something experienced across the country or only in some parts? It is experienced in the region of Kerala and Karnataka coastline. That is what helps in early ripening of mangoes. But do we have mangoes to be present only in this part of the country, or do the mangoes exist in other parts of the country as well? So they exist in other parts of the country as well. So when you have a hailstorm, and hailstorm means what? You have hailstones which come along with it. So when those hailstorms, they are happening where as of now? They are happening in northern part of the country due to western disturbances. So when they hit the mango tree, will they lead to the blossoming of the mango or will they lead to the destruction of the mango? So convective pre-monsoon showers, which happens in Kerala and Karnataka, that is very different from what is happening in North India right now. North India, please understand, anybody who has got the misconception that this is pre-monsoon shower in North India, that is not so. It is the presence of the western disturbances, as I have mentioned again and again, that continues up for a couple of instances even in the month of April. So it is that part of western disturbances which is causing thunderstorms and hailstorms in the northern part of the country. Okay. Right. Can we move ahead? Right. And Okay, let's move ahead now. Where more oceanic currents are experienced, Sukanya, across all the oceans? Amit, if the trade winds come from northwest, why will the trade winds come from northwest? Amit, trade winds in the northern hemisphere come from northeast to southwest, and in the southern hemisphere they come from southeast to northwest. So the direction that you are referring to is very different. Now we come to the portion of the various different ocean currents in different oceans. Understand this phenomena carefully for individual ocean, and that will be sufficient for your understanding in other portions as well. Understand how these ocean currents are generated and what is their movement thereby. So we start with the portion of North Atlantic first. That is what we will start to look at, and then after that we will follow the same approach in the region of South Atlantic. So when we take a look at the Northern Atlantic region, here in the region of North Atlantic, you do have in the lower latitude there is increased heating. So due to that increased heating, water will expand, and then the prevailing wind will provide the direction and channelization to the water. So as the water tends to expand, what is the existent wind pattern in that region? Here you have trade winds which are in play. Right? Now, what is the general direction of motion here? The general direction of motion around the equator is from east to west. We have looked at even in the case of ENSO cycles, it is the general direction of motion is from east to west. So these winds, they will be pushing the water from east to west, isn't it? So here, take the case of Northern Atlantic. So here the water is generally pushed from east to west owing to the trade winds. So here you have trade winds. Then after that, something very similar is observed in the southern hemisphere as well, immediately to the south of equator as well. Now from both the hemispheres closer to the equator, water is moving from east to west. And then it continues to move till it hits the Brazilian coastline here. Now upon hitting the coastline, look at the shape of the coastline. We have seen that shape of the coastline is an important factor. So the shape of the coastline basically diverts the current in the northern hemisphere slightly to the north. It will push the current slightly to the north. And as the current is slightly pushed to the north, you will have the role of Coriolis force also coming into the play. So the wave or the current will then start bending to the right as well. Here, these oceanic currents, they encounter the Caribbean islands. That is the region around Trinidad, Tobago, Jamaica, all these areas. That is Barbados, Bermuda, these areas, the Caribbean islands, or also the chain known as Antilles Islands. So when it encounters these islands, the ocean current experiences an obstruction. Now, when it experiences an obstruction, then what will happen? It will bifurcate into two. It will divide into two. So here you have the ocean currents getting divided into two parts due to the obstruction faced by the Caribbean islands. It is divided into two parts. One part of the ocean current travels to the north of the Caribbean islands. The other part moves to the south of Caribbean islands. Now, the one which moves to the south of it, eventually through this region, this is the area which is referred to as the Yucatan Peninsula. So through this area, it enters into Gulf of Mexico. And there, it enters into Gulf of Mexico, it circulates through the Gulf of Mexico, and then it comes out in the region around the state of Florida, which is present in United States. This is the state of Florida in eastern United States. That is where state of Florida is situated. So across the region of Gulf of Mexico, this circulation will continue, this water movement will continue, and then this water will exit itself into the Atlantic Ocean again. Now, when it is exiting into the Atlantic Ocean, what will be the temperature of this? Will the temperature be high or low? It will be high because it is coming from lower latitude. So the temperature will be high in this area. But here, this is joined by another branch of oceanic current, which is coming from the northern end of the Caribbean islands. That joins it. Now, obviously, the amount of water which is present, the Florida current which was coming. Why the name Florida current? Because it is coming from the region around the state of Florida in United States. Hence the name Florida current. Now from the Florida current, as the water is coming, it is joined by another water current. So what will happen to the volume of water which is flowing? Volume of water which is flowing is set to increase, almost double up. And both of these are going to be warm. So the temperature is also going to be high. So both of them together, they make up a very strong warm current, and that is what is referred to as the Gulf Stream. Why the name Gulf Stream? Because this current has come from the region of Gulf of Mexico. After moving through the region of Gulf of Mexico, after exiting from the region of Florida, that is where this has come. Hence the name Gulf Stream. Now it tends to move and it bends to the right, isn't it? Due to Coriolis force, it will bend to the right. Now, here, it keeps on bending to the right. Meanwhile, from the higher latitudes, you have waters which come in. Now, why will the waters come in from the higher latitudes? Till now, we have seen that water from the lower latitudes itself are carried to the higher latitudes. What do you think can be the reason that water comes from higher latitudes as well? Let me see. Anybody of you? What do you think can be the reason why you have water from the higher latitudes coming in? Devansh, very good, my dear friend. Beautiful. Shamil, you are also very correct. So is Sumit. Pravalika also. My question is, why does water come from higher latitudes? So obviously the answer cannot be for fishing. It is not as if that ocean currents know that, okay, fishermen require some amount of fishes, so let us circulate cold water. Question is, why does it come from higher latitude? Because of the presence of winds. Which wind? Polar easterlies. Polar easterlies, they generally move from east to west. But then depending on the shape of the coastline, they are unable to carry water through the west, but nonetheless, they are able to initiate a motion. And that motion which is initiated, that forms a part of the higher latitude ocean currents. So all these currents that you see, that is the Labrador current, Greenland current, which come from higher latitudes, their motion is initiated due to the presence of polar easterlies. Okay, so this motion is initiated due to polar easterlies. Now, when you have these cold currents which come in near the region of Labrador Islands, these cold currents, they come in. That is why the name Labrador current. And near the northeastern portion of North America, around the northeastern portion of Canada, around Nova Scotia and Newfoundland, around that region, you have this cold current which meets with the warm current of the Gulf Stream. So here, this portion experiences a mixing of cold and warm ocean current. Now, whenever you have cold and warm ocean currents which mix together, that many of the times increases the oxygen amount or the dissolved oxygen present there. that further boosts the phytoplankton population. Once phytoplankton population is boosted, that will increase the fish population, and that is why these areas where the cold and the warm ocean currents meet, they become very ideal fishing zones. But we'll come to it later. We'll talk about why ideal fishing zone, where else in the world do we have these phenomena. We'll come to it later. As of now, let us only understand the feature of this current movement. Here you will observe that this Gulf Stream starts bending to the right under the influence of the Coriolis force. Meanwhile, it is met by the Labrador current as well. Now, this Labrador current, when it meets here, it will also bend to the right ever so slightly. Here also, you will have this cold current. Now, in this region, if I were to ask you, what is the wind pattern which is going to be prevalent in this region? What do you think? What is the wind pattern which is prevalent in this region? Beautiful. You will have the presence of westerlies, isn't it? So wind pattern is westerly movement, that is from west to east. So this wind pattern will further carry the Gulf Stream. It will provide some further momentum to the Gulf Stream. So for a brief moment in this region, the currents are carried only due to the westerlies. That is the only factor carrying the current. So in that brief area, it is also referred to as the west wind drift. Drift means a very slow moving water, and a slow moving water only due to the influence of wind pattern. That is a drift. Now, what will be the temperature of this drift in comparison to the prevalent temperature at these high latitudes? We have waters which are being brought from lower latitude. So the west wind drift comparatively, very good, will be warmer than the surrounding water temperature. Now it is here that this west wind drift, it starts gaining momentum, and also it starts dividing itself into various subportions. That is when it is known as North Atlantic drift, because it is happening in the region of Northern Atlantic, and it is carrying warmer waters from the lower latitude, the same warmer waters from the lower latitude. All the meanwhile, if I still compare the temperature of this point A and this point B, you have to understand that the temperature of water at point B will be lower in comparison to A. That is, water at B will be slightly cooler as compared to A. But at that latitude, it is still very warm. And then this North Atlantic drift, it divides itself. It divides itself into various subparts. One of them goes towards the region of Norway. It is referred to as Norwegian current. One of them goes in between the region around North Sea. One of them goes around the region of Bay of Biscay. So you have multiple divisions of this North Atlantic drift. And you have the divisions as Irminger current, Rennell current, etc., but not required for your general studies. So let us ignore that. Just understand that this North Atlantic drift is a warm ocean current which brings warmer waters into higher latitudes. And this North Atlantic drift, because it is bringing warmer waters to the higher latitudes, that is the reason why in the Northern Atlantic, despite the surrounding areas becoming cold, the water body remains ice-free for most of the year because of the warm currents or warm waters brought by the North Atlantic drift. And that is what opens up this area for navigation as well, for ship movement as well. That is what opens up this area. Now, here, again, the shape of coastline will come into play. The Coriolis force will also come into play. So this water movement or the circulation will again be bending to the right. But this time around, you have water from the higher latitude which is coming to the lower latitude, isn't it? So water from the higher latitude it might even be, let's say the temperature of this water, let's assume is 15 degrees Celsius. Let's assume 18 degrees Celsius. But water at lower latitude is around 24, 25 degrees Celsius. So around the region of Canary Islands, around the region here you have the Canary Islands, around that region you experience a movement of water which is colder as compared to the surrounding water temperature, and that is what forms the cold Canary Current. That is what completes the circulation and feeds the water back into this North Equatorial Current. So that is how the entire circulation is achieved in the Northern Atlantic Ocean. I will repeat it again, then I will move to the Southern Atlantic, and then I'll be taking questions. So all of those who have slightest of doubt, don't worry, listen to this carefully again. What happens? So here when we talk about Northern Atlantic, you have to understand that at the region of the lower latitude, there is an expansion of water due to heating. Now that heating provides the expansion, so water gains a kind of a height at lower latitude around the region of equator. So when water gains a kind of a height, then it will move to the regions where you have the height which is less, always. It will end up moving to the regions where the height is less, but it will be channelized by the wind pattern as well. So what is the wind pattern at the region of the lower latitude? At the lower latitude, you have the prevalence of trade winds. And these trade winds, they move in a general direction of what? East to west. So all that raised up water is pushed due to the trade winds in the western direction. Now, as it is pushed in the western direction, it will hit the South American coastline. Now, the South American coastline, if you observe especially in the case of Northern Hemisphere, you will observe that the shape of the coastline pushes the water slightly to the north. That water which is slightly pushed to the north, further bending will happen in the right due to Coriolis force. So it will bend ever so slightly. Then as the water is moving, it encounters the group of Caribbean islands, Barbados, Bermuda, Trinidad, Tobago, Jamaica, all these group of islands it will encounter. Now these islands will offer a kind of an obstruction to the otherwise North Equatorial Current. So that is where they get bifurcated into two. One portion moves to the north of these islands, the other portion moves to the south of these islands. The portion which moves to the north of these islands, that eventually joins later. The portion to the south, that enters through the region of North America, it enters into Gulf of Mexico. It circulates through the region of Gulf of Mexico and exits from the region of Florida. Exits from the region around Florida. That is why here this is referred to as the Florida Current. Then furthermore, as it exits as Florida Current, it is joined by warmer waters coming from the northern part of these island group. It is joined by this water coming from here. So the volume of water increases. Both of them are warm. So that is why it becomes a warmer current. And as the volume of water increases, that is what forms a very strong warm current in the form of Gulf Stream. That Gulf Stream moves, bends to the right under the influence of the Coriolis force. Meanwhile, around the region of Newfoundland, that is the northeastern part of North America, it is joined by cold current coming from the higher latitude, that is the Labrador Current. Now, as it comes in, this slightly lowers the temperature of the Gulf Stream, but not significantly enough, because the Gulf Stream is carrying huge amount of water and Labrador Current is not as strong. It is very weak as compared to the Gulf Stream. Gulf Stream is one of the strongest ocean currents in existence across all the various oceans. So when this Gulf Stream then further moves, here it comes under the influence of westerlies. And that is when the westerlies, they carry it in general from a west to east direction, taking it closer to European coastline. When it comes to the region of European coastline, there it is referred to as the North Atlantic Drift. Drift again refers to a slow movement of oceanic water under the influence of wind. So whenever you have a slow movement under the influence of wind, that is a drift. So it moves west to east in a slow process. As it moves, the North Atlantic Drift then encounters the various different types of coastline. And also, remember, we have seen the mid-oceanic ridge in the form of Weichsel-Thomson Ridge. That also leads to trifurcation of these currents. So you have one portion which goes near the region of Iceland, another portion enters through the region into the Scandinavian countries, that is the Norwegian current, another portion enters here through the region of North Sea, another portion here moves through the Bay of Biscay and comes back. One portion, in fact, even moves through the Strait of Gibraltar and enters into Mediterranean. So that is the North Atlantic Drift, where the water is much warmer compared to the surrounding conditions. And hence it is referred to as a warm ocean current. Why? Because it is warmer as compared to the surrounding waters. But then again, this will experience a bend to the right due to Coriolis force. So here again there is a bend to the right due to Coriolis force. Now you have water which is coming from higher latitude to lower latitude. Whenever you have water coming from higher to lower latitude, generally, in comparison, the water will be colder. And that moves around the Canary Islands. Canary Islands, around which you also experience very frequent volcanic eruptions. La Palma eruption, the very famous La Palma eruption in Atlantic, is very close to these Canary Islands. So there you have these waters coming from higher latitudes, which are colder than the surrounding. And that is what forms the cold Canary current, which feeds back to the entire circulation. This circulation, you will observe, as we have seen in the case of Coriolis force, it is clockwise in the northern hemisphere. What about the southern hemisphere? Will the process be any different? The answer is no. So in the southern hemisphere, also around the region of equator, there will be a kind of a bulge. There will be a kind of an expansion around the region of equator. The trade winds will push the water to the west, isn't it? This will also hit the coastline. After that, you have the water diverting to the left because it is southern hemisphere. When water diverts to the left, that is when you have the warm Brazil current. Now, to the south, closer to the region of Antarctica, all around the region of Antarctica, we have the presence of an ocean. What is the name of the ocean which surrounds Antarctica? Let me see if we have an awareness of that. It is the Southern Ocean. So the ocean surrounding Antarctica, that is the Southern Ocean. So Southern Ocean always has a continuous motion due to the westerlies, which are very strong in southern hemisphere. So in Southern Ocean, you will always have a continuous west wind drift. Now here, this west wind drift which moves around the Falkland Islands which are present here, some of that west wind drift will also deviate to the left, and you have the Falkland current which is slightly colder. It meets with the Brazilian current, and then eventually this Brazilian current becomes a part of this cold west wind drift. This cold west wind drift then further some part of it will bend to the left due to Coriolis force, and it will be circulated as the cold Benecuella current, which will again feed the south equatorial current in the southern hemisphere. Now here you will observe something mentioned as counter-equatorial current. What is this? What do we understand by counter-equatorial current? So here you will observe that both in the northern and the southern hemisphere, you have the north equatorial and the south equatorial current which carries the water here to the South American coastline. Across the South American coastline, there will be some significant accumulation of that water, and the water will initiate a kind of a flow back as well. So after the water gets accumulated here, while some part of it will be deviated to the north as the Caribbean and Antilles current deviated to the south as Brazil current, some of the accumulated water, they will start a flow back owing to the rotation of the planet from west to east. So as the planet is continuously rotating from west to east, that will induce a motion, and that will bring back the counter-equatorial current. This counter-equatorial current is in existence across all the oceans around the region of equator. So that is how you have the circulation. Okay? Right? So I hope this is clear. Now, a couple of questions I will take. Yes, Sahil, that is true. It will bounce back due to the coast. As Mediterranean Sea is also so warm, so it will also expand. So how it can be allowed to an Atlantic drift current in the Mediterranean Sea. So that is where you don't have significant amount of water coming into the Mediterranean. But please understand, even if the Mediterranean is very hot, right, it won't be a condition that the height of Mediterranean waters is greater than the water at the same latitude. The height can be greater as compared to higher latitude, but across the same latitude, there won't be a variation in height. Otherwise, the water from Mediterranean, expanded water from Mediterranean, would have flowed into the region of Atlantic Ocean. So at the same latitude, it is consistent. Okay. Which current develops into Beniguela current? Vaishna, it is the west wind drift which bends to the left. Arindam, can you explain second portion, the southern hemisphere? Is it what you are asking, Arindam? So in the southern hemisphere, the south equatorial current, just like the north equatorial current as it is generated in the northern hemisphere, south equatorial current, upon hitting the Brazilian coastline, deviates to the left because we are in southern hemisphere. There it is referred to as the Brazil current. There it meets the cold current coming from the region of Falkland Islands, which is referred to as the Falkland current, just like the Labrador current in the north that you have. And there, eventually, that Brazil current then again bends to the left, becomes a part of the west wind drift, again bends to the left. Now, this time it is bringing waters from higher latitude to lower latitude, so it will be colder water, and that is why it is cold Beniguela current. How can west wind drift generated, Sachin? It is simply the carrying over of the momentum of the Gulf Stream owing to the presence of westerlies. No, Sushi, counter-equatorial current is present at the region of equator itself. Gagan, when ocean current hit any country like South America, can it lead to... Ocean currents never hit the coastline. Ocean currents will move somewhere away from the coastline or 50-100 kilometers away from the coastline. That is where the currents will be moving. It will not be approaching the coastline directly. It will be deviated from the coastline. Priyanka, how counter current works? Counter current works because when you have north equatorial and south equatorial current, both are able to carry water. You have accumulation of water, significant accumulation of water here, and some portion gets diverted to the north, some portion gets diverted to the south, but the rest of the accumulation, due to the rotation of the planet, it will not stay static. It will also follow the direction of rotation, and that is why you have counter equatorial current. Does that North Atlantic drift take place due to mid-oceanic ridges? Biswajit, no. North Atlantic drift is simply a carrying forward of the west wind drift, and here you have the warmer temperature because water is brought from the lower latitudes, and that is where after North Atlantic drift moves into, that is when it is impacted by the presence of mid-oceanic ridges. Siddhant, how Canary current loses temperature? Canary current is cold, Siddhant, because it is bringing water from higher latitude to lower latitude. So the temperature of this west wind drift might be around, let's say, 20 degrees Celsius. And here the prevalent surrounding temperature, if it is 15 degrees Celsius, obviously it is a warm current. But this 20 degrees Celsius, when it comes into an area where the surrounding temperature is 24 degrees Celsius, it will always become a cold current, isn't it? Won't the thermohaline circulation will not bring cold water current from polar? It will bring, but at the lower levels, below the surface, not at the surface. This is the surface phenomena that we are looking at. In lakes and small seas, water moves or not? No, not considerable to what we are seeing here. Pranay, North Atlantic drift increases salinity, yes. And frontogenesis is seen as the meeting of warm and cold ocean current very rarely. Generally, you will observe the formation of a fog. As warm and cold water meets, generally you will observe the formation of a kind of a sea fog and advectional fog of sorts, and that creates a nightmare for navigation. Okay. Will easterlies not affect the North Atlantic drift? No, because this is a region around 60 degree that we are talking about. Easterlies are in existence slightly beyond. So here you have the warm waters which are carried, and please understand the momentum. Gulf Stream is bringing water with a significant force. Westerlies further accelerate the movement. It is not as if North Atlantic drift is generating water on its own. So that is why even if it experiences the resistance from easterlies, its speed will slow down, but it will not come to a stop. Are the fishes use these currents? Fishes use these currents to navigate from one area to another area. Yasir, where both currents meet, there will be large amount of marine life. Yes. Amit, Brazil current meeting to west wind drift, then how it diverts towards Beniguela? Again, it will divert to the left due to Coriolis force, won't it? Here again, if you think the water is moving, it will divert to the left due to Coriolis force. That is why you have the Beniguela current. Okay. Yes, this mechanism is similar in the Pacific and the Indian Ocean as well. Does Canary Current encounter temperate cyclone? Sometimes, yes, but you have the formation of significant temperate cyclones occurring in the region of Mediterranean, especially during winter in this area. Typical speed of current, Srikanth, varies from one current. Gulf Stream, for example, is the fastest, one of the fastest. So you have the speed in such a way that you have close to around 72 billion gallons of 72 million gallons of water being transported every hour. So that is how high the speed can be. Okay, I hope this is clear. So here, one thing that we will take a look at, and after that I'll give you a break. So here, when we talk about the meeting areas of warm and cold ocean current, wherever the warm and cold ocean currents meet, that will always lead to the increase in the fish population, and these serve as ideal fishing grounds. Meeting point of warm and cold ocean current is always going to create ideal fishing ground. Okay. Is this circulation important for mains? Absolutely yes. You get questions from this in the mains examination. So ideally for your prelims also, you should be aware which currents are present in which ocean, and also whether the current in question, if I ask you the question, Gulf Stream is warm or cold, Canary Current is warm or cold, so you should have that amount of clue. It will come to you. As of now, it might seem too much amount of information, but it will come to you, and that will be easier. We will take the questions later in the session. And Arindam, my dear friend, please, you have the tablet videos, I hope. Look at those tablet videos. Let that sink in slowly. That will also help you. Okay. So if you want to find a way, there are many ways which will lay in front of you. Harshita, Falkland Current, another part of the west wind drift. Here, some portion gets deviated to the left under the influence of Coriolis force near the region of Falkland Islands. That is Falkland Current. How it is ideal fishing ground? Because the fish population is very high, so the fish catch is very high. Okay, so now let us take a break. Okay, and we'll be meeting at 6:50. Why doesn't counter equatorial current have effect of Coriolis force, Keshavi? Because it is at equator, exactly at equator. Okay, so let's take a break and let's come back, and then we will take a look at the circulations observed in Pacific and Indian Ocean as well. A confirmation for the audio, please. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. So now we shall be looking at the similar formation of ocean currents which are observed in the case of Pacific as well as the Indian Ocean. Now, Anil, I'm from Jammu. So yesterday it's raining here to see the location of winds, but there is no presence of westerly to Jammu side. So see, in the region of Jammu, it is not oftentimes, Jammu Kashmir, Ladakh, it is not oftentimes indicated on the weather map because of the presence of so many mountains in that region. That is why the wind pattern is not very consistent. That is why oftentimes in satellite map that observes a kind of a distortion. But the region around Jammu, northern part of India, they are receiving rainfall as of now because of the traveling low pressure systems which are coming from the Mediterranean, which form a part of the western disturbances. Okay. Now we come to the portion of the Pacific Ocean. Now, when we analyze the Pacific Ocean currents, here also you have to observe the similarity in terms of movement that we have seen in the case of Atlantic Ocean. So first of all, around the region of equator, due to intense heating, there will be slight swelling up of water which is going to be present. Water's height is going to increase by roughly around 5 to 10 centimeter. Now here in this area, you will also have the presence of these trade winds. The trade winds. Now these trade winds here also will be able to generate a north equatorial current. That north equatorial current will move all the way across to the region of the Western Pacific. And there, owing to the shape of the coastline and the Coriolis force as well, it will then move to the right. Okay, Coriolis force bending to the right. Now there, from the region around Japan, here you will find that these currents, they face a similar obstruction as was the case in the situation of Caribbean islands. Here also it follows the same kind of an obstruction. So here you get a division in the form of Tsushima current, which moves to the west of Japan, and a very warm Kuroshio current. Kuroshio current moves across to the eastern coast of Japan. There, as the Kuroshio current moves to the north, it is then joined by a cold current. Just like in the case of Atlantic, we had the Labrador cold current. Here you have the cold current in the form of Oyashio current. That is the cold current which joins the Kuroshio current. So here also, what you will find in presence, the existence of ideal fishing zone. Then further on, it is carried by the westerlies. Westerlies, they will be in prevalence, and there will be a rightward bending due to Coriolis action again. So as the westerlies are in prevalence, they will be carrying water in general from west to east. And as it is carrying water from west to east, that is what forms the North Pacific current, very similar to North Atlantic drift in the case of Atlantic Ocean. This North Pacific current, it will encounter the landmass in the form of North America. As it encounters the landmass, it will bifurcate into two. So here also the shape of the coastline becomes an influencing factor. Now this North Pacific current, which is warm, as it moves into the higher latitudes closer to the region of Alaska, the ambient water temperature or the surrounding water temperature around Alaska, that will be significantly colder, isn't it? Why it will be colder? Because we are talking about higher latitudes. Now, in those higher latitudes where you have cold waters, this North Pacific current, a portion of it enters in the form of Alaska current. So that is where it will be warm Alaska current, comparatively warmer. Whereas the same water also moves into the region closer to the tropics or the equator. And it brings water from higher latitude to the lower latitude. And that is why, as compared to the surrounding water, this water will be colder. Colder in comparison. It will be significantly colder in comparison. And that is what brings the cold California current, very similar in existence to the cold Canary current, which we saw in the case of Atlantic Ocean. Here also, very similarly, you have the presence of cold California current. In the southern hemisphere, that is the South Pacific, here again, water will be moving from east to west under the influence of these trade winds. So as the water, it moves from east to west, that is what forms the South Equatorial Current. Here also there will be some pileup of that warm water. Some of that warm water will start to flow back under the influence of the rotation of the planet across its axis as the planet rotates from west to east. So all this accumulated water also ends up traveling very slowly from west to east and thereby being able to generate a counter equatorial current. This counter equatorial current in general, across all the oceans in general, is a weak current. A weak current. Why? Because the availability of water is not so high, right? So availability of water to flow back, that is not very high. During the conditions, remember when we were talking about El Nino conditions, during the conditions of El Nino, we observed that there is a flow back, right? I hope that you still remember what we read in the first part of the week. So during the conditions of El Nino, there is a flow back and water flows from West Pacific to East Pacific. Only during those times will the counter equatorial current get stronger. Otherwise, it is generally weaker and it comes into existence only due to the pileup of water here and its subsequent movement due to the rotation of the planet. Then the South Equatorial Current will bend to the left again under the influence of Coriolis force in the southern hemisphere, and that is what generates the warm East Australia Current. In the case of Atlantic Ocean, if you find a similarity to East Australia Current, what will be the similar conditions in Atlantic Ocean? What is the corresponding current that you can name in the case of Atlantic Ocean? Very good. It is the Brazil Current, very similar to the Brazil Current. Here you have the East Australia Current. Here, by the way, you will observe some part of this water enters into the region of Indian Ocean as well. And that keeps on moving into the Indian Ocean very slowly. By the way, this Australia current, that is East Australia Current, again after that will bend to the left owing to the Coriolis force. It again forms a part of the cold west wind drift present in the Southern Ocean. This west wind drift is in existence because of what? Due to the prevalence of which wind pattern? Very good. Prevalence of westerlies. Okay, so here that is why they are moving from west to east. Now as they are moving from west to east, here again they will be deviating to the left, and here you have the generation of the cold waters which are brought from the higher latitude to the lower latitude in the form of the cold Peru current. The similarity between the Atlantic and Pacific in case of Peru current, what is the counterpart in the Atlantic Ocean when we talk about Peru current here? Beautiful. It is the Beniguela current. Okay, so that is how the entire circulation is achieved, even in the case of the Pacific Ocean. Okay, now we come to the Indian Ocean. Indian Ocean, for the southern hemisphere, will observe the similar kind of movement pattern as you observe in South Atlantic, as you observe in the South Pacific as well. So southern hemisphere of Indian Ocean will experience the same movement, right? It is the northern part of Indian Ocean which experiences a unique movement. What can be the reason for that? If you simply compare the Indian Ocean with the physiography of the Pacific and the Northern Atlantic, you will observe that North Atlantic is also open, North Pacific is also open, but Northern Indian Ocean, it is closed, almost landlocked feature. So when you have such a landlocked feature, the influence of the wind pattern gets very, very strong. So here, when we talk about Northern Indian Ocean, it is landlocked or surrounded by land. Very closely. Due to this, influence of wind and shape of coastline becomes exaggerated. Now, in the Northern Indian Ocean, while studying the portion of Indian monsoons, we have studied that in the Northern Indian Ocean, you have a significant reversal of the wind direction. In the month of advancing monsoon, the wind direction is in what pattern? In the month of advancing monsoon, the wind direction is southwest to northeast. Southwest to northeast. So that is why during the months of advancing monsoon, in the Northern Indian Ocean, you will observe that the winds, they end up exhibiting a kind of a clockwise circulation due to the movement of the wind from southwest to northeast. Whereas when we have the retreat of the monsoon or the northeast monsoon, which comes into existence during the months of November to around February, that is when the wind direction actually ends up getting reversed during the conditions of northeast monsoon. So that is when you will observe that the direction of motion of this circulation completely reverses. This is a feature you don't find in North Atlantic. This is a feature you don't find in North Pacific. Why? Because they are open. They are not bounded by land and they don't experience such reversal of wind in very close quarters. But in the Northern Indian Ocean, you experience that. That is why you have reversal of the ocean currents. Now, the Southern Indian Ocean will follow a factor or a pattern very similar to the other oceans that we have studied. Here, in the Southern Indian Ocean, you will find you have the South Equatorial Current. It will bend to the left, right? You have the Mozambique and the Agulhas Current, similar to the Brazil and the East Australian Current that we had. This will continue to bend to the left. And there you have the cold west wind drift. West wind drift is supported by which wind pattern? It is supported by prevalence of westerlies, right? West wind drift supported by westerlies. There again, it will bend to the left owing to the Coriolis force. Here again, you have the cold Australia current, West Australia current rather. This cold West Australia current, meanwhile, the one which was coming from the Pacific Ocean, if you analyze here, one ocean current was coming from the Pacific entering into the Indian Ocean. That is the very weak Lewin current. This is again in general weak current. Weak current. Okay, that is also what is referred to. As Lewin current. So that is what completes the circulation. Australia current very similar to the Peru current, very similar to the Benguela current, and that is where here again on the west coast of Australia you will find the cold West Australian current. That is how you have the circulation which is achieved in all the various different oceans. Okay. La Nina water taken by Leuven current to Bay of Pranay. Yes, very good. And how can we identify warm and cold currents? If the water brought by is colder than the surrounding temperature, it is cold current. If it is warmer than the surrounding temperature, it is warm current. Okay. Counter current is when you have significant accumulation of water around the region of equator owing to the movement of the planet on its axis from west to east. That also, due to inertia, observes some motion from west to east. That is what is counter equatorial current. Why south equatorial current bend to the south if ITCZ is on India? South equatorial current. So why will south equatorial current cross equator here, Srikant? South equatorial current will follow the normal trend, and eventually, here again, if you look at the wind direction, you will observe that the wind direction, even during the case of advancing monsoon, what is the wind direction? Wind direction in the southern hemisphere also, if I have to represent, the wind direction is very much like this. And then it crosses the equator and then it reverses. Right? So for all this portion, it will be carried to the west and then it will start deviating to the left. Okay? Right? Reversal of current in North Indian Ocean, Amit, that is what we have said, that in the case of the Northern Indian Ocean, unlike the case of Pacific and Atlantic, it is closed from the north. That is why the shape of the coastline and the influence of the winds get exaggerated. And because the wind direction gets reversed, hence the circulation also gets reversed. Counter equatorial current, Vijay, will also be present in Indian Ocean. It will be weaker in certain seasons and stronger in other, depending upon the circulation in the Northern Indian Ocean. Okay. Now we come to the portion of AMOC, or Atlantic Meridional Overturning Circulation. This is what is also referred to as AMOC. Now, here, this is a part of, basically, what you see in front of your screen is a part of a global circulation. Now, this global circulation that you observe, it is not happening on the surface, but rather it is a part of both subsurface as well as or as a part of surface as well as subsurface circulation. Now, this kind of a circulation we have studied earlier in the portion or in the part of thermohaline circulations. Thermohaline circulations. So basically, here, what happens due to the influence of temperature and salinity conditions? Lighter water or water of lesser density rises up around the lower latitudes, sinks in the higher latitudes, isn't it? Now, this is something which is observed to happen across various different oceanic areas. And this leads to mixing of oceanic waters amongst all of them. It mixes the oceanic water in between the Pacific, Atlantic, and the Indian Ocean as well. Now, this takes close to around 1,000 years to complete one circulation. So it is not a very quick or a fast circulation which happens. It happens at its own pace. When you have warmer waters here, this representation that you see, this is a part of the Gulf Stream. Even though the representation is slightly incorrect, but it is a part of the Gulf Stream here. So when the water moves to the higher latitudes, the water loses temperature. It becomes colder, means more dense. It becomes more saline due to freezing activity. So it will sink. It will pass on as subsurface phenomena and it will continue to move across the various different oceans. It is very similar to a kind of a conveyor belt system. The conveyor belt system that you observe generally in the case of your malls, your escalators, in your flour mills, etc. When you go through, you would have observed a conveyor belt, isn't it? Where you have a kind of a rotating belt system. You would have observed this. So such kind of a circulation is observed across the global oceanic waters as well. And this circulation, which is a kind or which is driven by thermohaline conditions, this is also what is referred to as a global conveyor belt. Global conveyor belt. Okay, it is very slow in motion, but nonetheless, it is very important for distribution of temperature and circulation of nutrients amongst different water bodies. Now, here, first of all, let me give you the text portion of it, which will give you some amount of relief. So, global conveyor belt is a system of ocean currents that transport water around the world. While wind primarily propels surface currents, deep currents are driven by difference in water densities by the process of thermohaline circulation. Now, density depends both on temperature and salinity. Along this conveyor belt, heat and nutrients are moved around the world in a very slow and a leisurely 1,000-year cycle. That is generally what you experience. Now here, it is a part of a global circulation. Now the portion of the Atlantic in this case, you will observe that the entirety of the Atlantic experiences a kind of a meridional circulation, that is across the different or across the similar meridian. So that is why it is referred to as Atlantic meridional overturning. Means water which is coming to the poles, to the polar region, it is overturning and moving as subsurface water. Hence, Atlantic meridional overturning circulation. So this AMOC is very much a part of the global conveyor belt system. Gulf Stream, in fact, is a part of the AMOC. As warm Gulf water approaches the North Atlantic, it cools, releasing its heat to the atmosphere. As it cools, the water becomes more salty and dense and sinks or overturns to the bottom of the ocean. The Gulf Stream and the AMOC are a part of larger process of thermohaline circulation, often nicknamed ocean conveyor belt or the global conveyor belt. Now, this is a portion which is very relevant for your current affairs in geography for the past couple of years. This AMOC has been in increased discussion. Why? So we'll take a look at it. So this ocean conveyor belt describes the interaction of surface currents like the Gulf Stream and the deep subsurface current across all ocean basins. So these mix ocean water, salt, and even organisms on a global scale. As ocean temperature and density contribute to temperature change in the atmosphere, the ocean conveyor belt also contributes enormously to the climate of our planet. So, it is a kind of an interplay between the oceanic circulation and in between the atmospheric circulation. How? Let us understand. So, here you have the Gulf Stream. Now, this Gulf Stream, when it reaches the poles, it will cool down and then it will sink. So anything which cools down means it will release heat. That is when it cools down because it is releasing heat. Where will that heat be released? In the higher latitudes. That is very important for the maintenance and distribution of temperature even in the higher latitudes. Isn't it? That brings about thunderstorms, rainfall in the higher latitudes. Otherwise, higher latitudes receive very limited amount of rainfall. Now understand why this is an issue which is in prevalence and is in news significantly for the past 2 years. Due to global warming, the polar temperature is increasing. Now, as the polar areas are becoming warmer, think about it. If the polar areas become warm, when this Gulf Stream reaches there, will it cool down as efficiently as it used to? Now that the polar regions have become warmer, will the Gulf Stream cool down as efficiently as it used to? No, absolutely not, because the polar regions are now warmer. Earlier they were cold, so the Gulf Stream immediately reaching there became cold and sunk. Now you don't have that cooling which is happening. Now, if the Gulf Stream is not cooling down, means it will not be releasing heat into the atmosphere. If that heat is not released into the atmosphere, means there will be less amount of convective rainfall in this area. That means the region around Northern Atlantic, the region around Europe in general, will it experience excess of rainfall or will it be devoid of rainfall? What do you think? Will it receive excessive rainfall or will it be devoid of rainfall? Very good. Absolutely devoid of rainfall, because now you don't have convective rainfall which is happening because the heat is not released anymore. This is one of the reasons why for the past 2 to 3 years, in fact 4 to 5 years, you would be observing that the region of northern Canada, the region of northern Europe, they are experiencing heat waves, very severe heat waves and drought-like condition. Because that heat which would be supplied above water body, that would lead to the formation of very significant cumulonimbus clouds. That is not happening anymore. Now, there are other implications. While this is leading to heat wave conditions in the region of Europe and Canada, at the same time, understand another feature. Earlier, this Gulf Stream was moving. As it entered a region of colder waters, it would become cold, sink, and a circulation would happen. Now, when the Gulf Stream is coming, it is not cooling down. So, if it is not cooling down, it will not sink. If it is not sinking, means what? It will lie where it is. Means what? The portion behind it will lie where it is. Means what? The portion behind it, that will also lie where it is. So, due to climate change, can we say that AMOC is slowing down? We can say that. So, due to climate change, AMOC slows down considerably. Now, as AMOC slows down considerably, means the same water is present in the same region for a longer duration. That is receiving heat continuously. Earlier, the water was circulating, distributing the heat, but now the same water is receiving prolonged duration of heat. Now, in a water body, when you have a prolonged heat which is received, what kind of atmospheric phenomena comes into existence? Beautiful. You have the development of cyclones. This is the reason why for the past 2 to 3 years, the entire region of Atlantic, especially northern Atlantic, that is frequented with a barrage of cyclones. So much so that for the past couple of years, North America the North American region, they have run out of the names to provide these cyclones. That is when they started naming them as Cyclone Alpha or Hurricane Alpha, Hurricane Beta, Hurricane Gamma, Hurricane Theta, Hurricane Delta, based on the Greek alphabets. Because the frequency of occurrence of cyclone has suddenly accelerated in the past 3 to 4 years. Why has it accelerated? Because the Gulf Stream has slowed down. Why? Because it is a part of a larger AMOC slowing down. Why? Because the polar region is warming. Why? Because of global warming and climate change. Okay? So by this, you are able to understand how the region of Europe and North America, northern portion of Canada and Europe, experiencing drought-like conditions is basically initiated due to oceanic circulation as well. And also why North Atlantic experiences so frequent occurrence of cyclones. This is again something that you won't find mentioned in the various different reference materials or any book that you buy in the market. This is something you won't find available there. So that is where you need to understand this, because these are the types of questions that UPSC is focusing upon right now. Okay? Now we come to the effect of ocean current. Now, when we talk about effects of ocean currents, here you have to understand that impact is both geophysical as well as economical and also on the human aspect. Ocean currents, they not only end up moderating the temperature, influencing the temperature in a certain area, they manage to keep an area ice free for most of the year, as we observed in the case of North Atlantic. And there they ensure navigation practices can be carried out, or movement of ships can be carried out throughout the year. Whenever you have mixing of cold and warm ocean water which takes place, that significantly increases the population of phytoplanktons, and these phytoplanktons are very vital for the fish population, and that is what contributes to the increase in fish population in that area. That is where you will observe that significant fishing grounds lie in areas where you have mixing of warm and cold ocean current. Then, the best fishing grounds of the world exist mainly in these mixing zones of warm and cold ocean current. There is another geophysical characteristic played by the cold ocean current, and that is cold ocean currents are responsible for creation of deserts in the western margins of continents. Why it is so? If you take the case of Canary Current, nearby that area you have the Algerian desert, the Sahara desert in general. If you take the case of the cold California current, there you have the Mojave desert. If you take the case of the cold Beniguela current, there you have the Kalahari desert, Namib desert. If you take the case of cold Peru current, there you have the existence of Atacama desert. If you take the case of West Australian current, there you have the existence of which desert? What is the desert which lies in Australia? I'd given it up for map pointing. So I want someone to give the correct answer. Very good, Pratyaksh. And Neil also, most of you. It is the Victoria Desert. Victoria Desert is present in Western Australia. So these cold ocean currents, wherever you find them, there you will find the presence of desert areas. Why is that the case? Let us understand. So here, imagine you have the water body. Imagine nearby you have the land area, the western coast. And I want you to think logically. I would be asking questions, you would be replying to it, and accordingly we will reach at the end of the concept. Here, you have the presence of cold currents. Cold currents, what will it lead to the ocean temperature? Ocean temperature will cool down, isn't it? So here you have the presence of cold water. Now, colder waters in this region, what will it do to the temperature of air in this area? Will the temperature be higher or the temperature will be lower? What do you think? Temperature will be cold. Low temperature. Now, when you have very cold air closer to the ground surface, what kind of atmospheric phenomena does it lead to when you have very cold air near to the ground surface? Beautiful. Here, this eventually leads to the condition of temperature inversion. In certain places, a localized high pressure is also created. So all those who have written a localized high pressure, that is also correct. So this leads to a temperature inversion. Now, whenever you have temperature inversion, in those areas, do you receive rainfall or is there a lack of rainfall in that area? What do you generally associate with when you talk about temperature inversion? Significant lack of rainfall? Significant lack of rainfall, and yes, correctly pointed out that you will have clear skies as well. So significant lack of rain. And when you have a significant lack of rain, that is what leads to desert formation. So that is why wherever you have these cold currents in existence across the margins of the continents, generally you will find conditions of inversion created, as a result of which you have a general lack of rainfall, which is resulted, due to which you have creation of a desertified landmass. Okay? Yes, Seni, that is correct. As I told you, in that localized area, you will have the creation of high pressure as well. Okay? Then we come across a unique feature that you observe only in the case of Northern Atlantic, and that is the formation of what we refer to as the Sargasso Sea. Now, Sargasso Sea is created or is a portion of water in the region of the Central Atlantic, North Central Atlantic, where, okay, why Arabian Peninsula is a desert? See, just because I told you that cold ocean currents lead to the desert doesn't mean it is the only factor. The region of Arabian Peninsula is a desert because there you have the trade winds which basically are continental in nature, so they don't bring in any moisture. So you have dry winds which come in. Also, you have periodic creation of high pressure zones due to sinking of air. That is what creates desert in that area. Okay. Yes, Pranay. So now we come to the Sargasso Sea. Sargasso Sea is generally observed in the region of Northern Atlantic here. Now, why is it observed? And why is it created? So Northern Atlantic is unlike the case of Northern Pacific. Northern Pacific is very wide. Northern Indian Ocean is very small. But Northern Atlantic is just the right size, so to say. And in this, the Gulf Stream in the west, then it bends in the form of west wind drift and North Atlantic drift to the north, then Canary Current to the east and North Equatorial Current to the south. So all this kind of a circulation which is observed, it ensures a movement of water along a kind of a spiral, but the central portion largely remains unimpacted and unaffected. So this central portion which remains unimpacted and unaffected, it is bounded by ocean currents from all sides. So this portion is bounded by ocean currents from all sides. Okay, so this is bounded by ocean currents from all sides. That means here the mixing of water from the other region, it is not as if water from here can come in this or water from here can come in this. No. So due to this, you have an absolute lack of mixing of water. Absolute lack of mixing of water. Due to which water is stagnant. But what if, why don't the other winds end up moving this water, as is the case with the general other currents that we observe? Why don't you think that the winds are able to carry this water away? Because this is a zone of high pressure. If you look at it in the module of pressure zones that we have seen, this is a portion very much of Bermuda High or the Azores High. So this is a region of high pressure zone. So a high pressure zone leading to a lack of wind movement. So there is no wind movement in this region. All around it, the circulation is happening. In this area, there is no circulation. It is almost stagnant. So what happens? you have seaweeds which start growing and blooming. These are your seaweeds. So in these areas, seaweeds, they start growing. And these seaweeds, while they are very, very beneficial for biodiversity, they are able to support a lot of biodiversity, right? They are able to establish an ecosystem of floating weeds. And these floating weeds, they reproduce from one another and they spread a larger area of this brown film-like covering that they provide. But at the same time, they pose a nightmare for navigation. So these seaweeds, beneficial for biodiversity, very beneficial for biodiversity, and at the same time, it is a nightmare for navigation. So seaweeds are also a category of algae, Pranay. Nightmare for navigation. Because oftentimes these seaweeds, as you can see, they will get entangled within the hulls and the propellers of the ships, and that is when the ship immediately becomes defunct in the center of the ocean. So because of the predominance of these seaweeds, the Portuguese explorers, in the Portuguese language, seaweeds are referred to as sargassum. They get the name sargassum. And from this sargassum, you have the name associated, which is Sargasso Sea. So that is how you have the presence of Sargasso Sea in the North Atlantic. Why not in the North Pacific? Because the North Pacific is so wide that you don't have such enclosed loop which is created in any particular portion. Similarly, in the North Indian Ocean, it is so small that there is no question and there is reversal of circulation there, which happens as well. Okay? So that is what is referred to as Sargasso Sea, bounded by Gulf Stream on the west, North Atlantic Drift in the north, then Canary Current in the east, and North Equatorial Current in the south. This is referred to as a sea which has got no coastline. Otherwise, all the seas that are named, they have a general coastline across it. But this is the only sea which is named, which has got no coastline. Okay, so that is where you have the formation of Sargasso Sea. Okay, and that finishes this portion, and now we come to the portion of coral reefs. How does the stagnancy of water in Sargasso? So wherever you have Vaishnav, wherever you have stagnant water, keep water stagnant in your own bucket for let's say a month or two. You will observe the growth of algal species and fungal species which will start happening. So the same phenomena happens on a larger scale. Why in temperature inversion no cloud formation is seen? Because whenever you have a cloud formation, for cloud formation, what is it that you need? You need a rising column of air. In the case of temperature inversion, you don't have any rising column of air because the cold air is already down and the hot air is already up. So because of that, no cloud formation. Kindly look at the annotations or the recordings of the sixth module. You'll get enough clue about it. Eutrophication is a different matter. Nitesh, eutrophication is due to nutrient overload. Here you don't have a nutrient overload which happens. Okay, so please don't think that this is a form of a eutrophication on a larger scale. And why does fog form when you have warm and cold ocean currents that meet? Because the warm current will bring warmer air above it, cold current will bring colder air above it. When they mix, you have advection fog which is created. AMOC is also affected by ocean acidification, that is true, but very little, very less. Okay. Now we come to the portion of coral reefs. Coral reefs are something that you will study in significant detail in the portion of environment and ecology, here we are going to cover only the geographical aspect of it. So when we talk about coral reefs, this is going to be relevant for your prelims, and also mains. In the prelims, you generally get questions for the portion of types of reefs, geographical spread, the various different threats encountered, and in the mains, you get questions for coral bleaching. Racha, do we have freezing rain in temperature? Only in the case of frontal inversion, you have that case. And Amit, how this mechanism studied on what basis? What mechanism, Amit? What mechanism is studied on what basis? So this is basically something that you will find in the case of coral reefs. Now, most of these, that is the conditions required for the growth of reefs, etc., you will study in the portion of environment and ecology. Here, as I told you, we are just going to cover it from the perspective of geography, that where, in what conditions do you find the growth of these corals? Atlantic Pacific Ocean currents. How this mechanism is studied on... Amit, I am unable to understand the question that you are posing, that Atlantic Pacific Ocean currents, how they are studied. We have also studied Atlantic and ocean currents. It is based on circulation. It is based on the factor that how is it that the currents circulate, what are cold currents, what are warm currents. That is the basic principle behind it. Yes, Vaibhav, that is correct. Nitesh, that is true. Deepika, Sargasso Sea is stagnant. True. No circulation means why weeds will grow. So if there is a significant circulation, will you observe the growth of weeds in that region? Think about it. In an ocean, if there is continuous circulation, will you ever observe a growth of weed in that region? Any kind of algae or fungal growth will you observe in that region? No. Think about it. Keep a bucket of water in the same area stagnant for 2 to 3 months. You will observe the growth of green algae around it. So when the water stagnates, that is when eventually the algae start growing from the microscopic level. You have the growth of the phytoplanktons initially, and that eventually forms and morphs itself into various different algal species. Okay? Right? So here we start with the coral reefs. The coral reefs, as you can see in the image, they present a very vivid picture. Now, these coral reefs, they are also referred to as tropical rainforests of the oceanic areas. Why? Because not only do they not only are they able to supply enough oxygen within the oceans due to the process of photosynthesis, but at the same time, they provide shelter to huge number of species. They allow a large amount or a large number of biodiversity to get shelter here. That is why you will find that these coral reefs are referred to as the tropical rainforest system or the evergreen forest system of the oceanic waters. Now, these corals that we are going to study here warm water corals. So you have different types of corals, warm water corals and cold water corals. Warm water corals generally grow in tropical waters where the temperature is generally around 24 to 26 degrees Celsius. That is where the warm water corals, they grow. And here, the ideal condition required for the growth of the corals is 24 to 26 degrees Celsius, whereby you will observe that at that temperature, the in the presence of sunlight, these corals, they carry out the process of photosynthesis and they are able to manufacture their own food. Okay? As seismic waves help to study continental, still your question is not clear. Amit, do one thing. Whatever you are thinking in your mind, whatever is your query in your mind, write it down in a piece of paper, take an image, send it to me by mail. Because as of now, it is impossible for me to take any sense of the question that you are asking. Okay? Write it to me by mail. I will look at it, I will examine it, and then I will get back to you. Okay? Fair enough. Now here, basically, if you take a look at it, the coral reef is an underwater ecosystem characterized by reef-building corals. So these coral reefs are a multitude of various different corals taken together. And all these corals basically are made up of individual coral polyp. So individually, they are referred to as a coral polyp. And there, these coral polyps, they live in a symbiotic relationship or a kind of a mutually beneficial relationship where both the organisms benefit from each other. And here they live in a symbiotic relationship with what? With an algal species. And that algal species is referred to as zooxanthellae. So this algal species lives in a symbiotic relationship with the coral polyp. The coral polyp, what it does is, it is able to synthesize the calcium and the carbonate ions which are present in the water around, and it is able to build for itself a strong calcium carbonate exoskeleton. Calcium carbonate, the thing that makes limestone, the thing which is used to make plaster of Paris and cement, etc. So it is naturally binding, and it is what has got a whitish tendency, whitish property, a coloration pattern to it. So that is how the corals, this are able to synthesize calcium carbonate from their surrounding and build this calcium carbonate exoskeleton around them. And the coral polyp, which is an individual animal, has got a very simple body morphology. Here you will observe the presence of tentacles. Tentacles. Now these tentacles are for what purposes? So that, by the way, these corals, they are not moving objects, they are fixated to the ground. So these tentacles, they basically trap any kind of moving nutrient or moving particle in the water and ingest it through this orifice or the opening that it has, and it is sent into the digestive tract. But obviously, because the organism cannot move significantly, its ability to take in food is also restricted. It is not limitless. Its ability to take in food is very restricted. So that is why it enters into the symbiotic relationship with the algae, the algal species. They are attached to these tentacles. And this algal species that is zooxanthellae. This carries out the manufacturing of food. How? By the process of photosynthesis. Carries out photosynthesis. So if it carries out photosynthesis, so can we not naturally come to a conclusion that these types of corals would be present only in photic zone? Isn't it? So that is why these are present. Hence, warm water corals are present in areas where water is shallow, level is shallow, and there is availability of sunlight. So which portion of the ocean bottom relief has got this feature that the water level is not very deep and you have the availability of sunlight as well? Which portion of the ocean bottom relief? Beautiful. Generally, very good, Seni. So generally, this is formed across continental shelves, as many of you have pointed out. Continental shelf, and as Abhishek and Seni have pointed out, on sea mounts as well. So it is in these areas where you will find the presence of these warm water corals. Now, the conditions required for warm water corals, if you take a look at it, warm water corals, the conditions required by them. So you require temperature around 24 to 26 degrees Celsius. The temperature should not change. It should be consistent. Then they require a condition of saline water. They don't grow in fresh water system. Saline water, lack of muddy deposition, etc. So wherever you have lot of sedimentation, there is no coral growth which is observed there. Lack of sedimentation. And also availability of sunlight. Availability of sunlight. Now together, these corals, they build up large systems joined by each other with the help of the calcium carbonate. That is when they are able to present such a vivid image. All these different coloration pattern that you see, that coloration pattern is provided by the algae, nothing else, right? So it is the algal species which provides that coloration pattern. So here, basically, the largest coral reef is the Great Barrier Reef, which is situated to the northeastern part of Australia, which spans close to around 2,600 kilometers in length. Okay. Now, how do they grow from one generation to other? We have seen how do they survive, but how do they grow? It is a very simple process. Basically, when you have the corals which are in existence, they will generate the calcium carbonate exoskeleton. Now, when those corals will die, they will leave behind the calcium carbonate. So, this is calcium carbonate. Then you will observe the growth of next generation of corals. And next generation of corals will be growing on a platform above that. Right? So they will also die. They will also leave behind a complete zone of calcium carbonate exoskeleton, which will be utilized by the next generation, which will be utilized by the next generation. So that is how on top of each other, they start and they continue to grow. Now here you have to understand that this is how in many of the cases, they can lead to the building of the island-like structure as well. So for example, when we talk about the corals, let's assume here they have grown, they have died. The next generation will grow on top of it. The next generation might grow on top of it further. Furthermore, the next generation will use that. Furthermore, if you observe the next generation, they will grow on top of this. Now, when they somehow come above water, that is when they will die. Because these are marine species. These cannot live above water. So when they come above water, that is when you will observe that these corals die. And then what do you have? You have a leftover calcium carbonate, isn't it? So here you have calcium carbonate. Now, along with the calcium carbonate, the action of the sea waves, they will also carry out some deposit. So on top of this, you will have sediments, very fine particles, etc., brought by the sea action. Sediments brought by sea. Now, these sediments, do you think they will consist of any nutrients or will they be devoid of nutrients? What do you think? What do you think happens? This, after the corals have died, after this deposition has happened, will they be devoid of nutrients or will they consist of nutrients? Very good, they will consist nutrients, right? They will be because what are these nutrients? These are various minerals and salts which are dissolved in the ocean water. They will be deposited along with it, some amount of them. Now, these form an individual island. Now, sometimes when you have islands in the middle of the sea, in the region around water body, many of the birds, they take shelter there. They take a break, especially the migrating birds, they take a break there. And when they take up a break there, they will maybe drop a seed or two here. And these seeds might grow. And you might observe the growth of trees in this region. Right? You might observe the growth of trees. These trees will also reproduce significantly, isn't it? So that is how you will have the entire population of these islands coming into existence, at least the wildlife coming into existence. So that is how, in many of the cases, you have the creation of coral islands, where they simply rise up above the water body, and that is when they create a scenario where after they have risen above the water body, they die because they can survive only underwater, and then due to deposition, sedimentation, and also the help of the other forms of biodiversity like birds, etc., you have the growth of plant species, flowering plant species, etc. Then you have other species sometimes which also inhabit this area, and that is how you have the establishment of many of the coral islands. Example of coral islands in India. Example, you have Lakshadweep. Andaman, in the Andaman group of islands, you have few of them like Havelock, etc., which is created due to coral action. But in Andaman, most of them are volcanic in nature. Okay? Right? Yes, Neil, that is also correct. It will happen. Now here, this is basically the distribution of coral reefs here. You will observe a great predominance of corals in the region around Indonesia and Philippines. Why? Because this is where you have a lot of small islands, so providing a lot of shallow areas near the water body. So that is why you will observe a lot of corals in this area. Now observe the region around India, in the region around Bay of Bengal. Now, UPSC had asked this question once, that in which part of India and coastline do you find the formation of corals? So one of the options given was Sundarbans. Will you find the existence of corals in the Bay of Bengal immediately around Sundarbans, or will that region be devoid of corals? And if no, why? Why do you think that there won't be corals in that region? Because of sedimentation. Sedimentation carried by the rivers, that is Ganga, Brahmaputra, that creates the deltaic region, due to which the region of Sundarbans is devoid of corals in general. Okay, wherever you have typically warmer waters and shallow coastline, you will find a lot of corals to be present in that area. This is the entire stretch from Lakshadweep all the way to the region of Maldives, moving ahead all the way till Diego Garcia, which has a large US military base in that region. Then when we talk about, can it survive in fresh water? No. Then we come to coral bleaching. What is bleaching? Bleaching is a name associated with generally whitening of clothes, etc. that you give. So these corals, when they have the zooxanthellae population, they appear somewhat like this. Now, due to certain harsh conditions or certain adverse conditions, such as sudden temperature change, pollution, overfishing in a way which uproots the corals as well, unsustainable methods of fishing, etc., oil spill, marine pollution, due to all those factors, the zooxanthellae population, that starts to die. The population's productivity also reduces. And as a result of that, when the zooxanthellae completely dies, the coral is left in its stony white appearance, and that is what is the phenomena is referred to as coral bleaching. So what is coral bleaching? When coral polyps lose their symbiotic algae, that is the zooxanthellae. Without it, the living tissues of the corals are nearly transparent. Stony skeleton can be seen. It is referred to as coral bleaching. Now, if it remains like this for around 45 to 60 days, that is around 1.5 to 2 months, now in that time duration, it generally gets a situation where there is a lack of food. It doesn't get enough nutrition. And when it doesn't get enough nutrition, that is when the corals will die. So coral bleaching eventually leads to the death of corals. And when you have the death of corals, oxygen generation in the oceans, that is impacted, support to biodiversity is impacted. That is why coral bleaching is absolutely harmful for the oceanic biodiversity. Okay? Now, here, when we talk about the types of coral reefs, the coral reefs basically are classified into different types based upon where do you find them. Generally, as happens in the case of the coastline, you have the emergence of land and you have the subsidence of land. Which force is responsible for emergence and subsidence of land? What do you think? Which is the force responsible for emergence and subsidence of land? Good. Aperogenic force. It is endogenic, but more precisely aperogenic in the category of endogenic forces. Very good, guys. So due to that, in areas, in many of the cases, even volcanic eruption leads to emergence of islands, and over a period of time they subside due to the endogenic forces which keep on acting from the interior. So that is why initially you'll find a group of corals at the coastline, on the fringing areas of the coastline, in shallow waters. That is what is referred to as fringing reefs. It is existent in the shallow waters on the fringing areas of the coastline. And then, after some time, you will observe that due to subsidence, as the central land simply subsides, those corals are left behind. They form a kind of a barrier around that sinking land. And here you have a creation of a lake or a lagoon of sort in between. This is what is referred to as a barrier reef because it forms a kind of a barrier around. When the central point completely subsides, you are left with an island of sorts, which only consists of those corals which are on the surface, which are dead but on the surface. That is an atoll, right? So you have three types of corals based upon where you find them. Let us take a look at each one of them one by one. Fringing reefs. So they will be formed across the fringing areas. Observe here also. Across the fringing areas, across the coastline. Right? So they are formed across the coast of continents or islands. Their surface is connected to the coast and rises up to the low tide level. Beyond the low tide level, it cannot exist because that would mean it is above water body, right? And above water body, it cannot survive. And it provides a kind of an uneven and rugged platform. As this central portion subsides or sinks, by that point of time, the coral would have built its own connection here. So the central portion, as it sinks, the coral tends to remain there, as you can see, creating a kind of a lake or a lagoon-like feature in between that sinking land. This forms a kind of a barrier, and that is what is referred to as a barrier reef. So wherever you find the presence of barrier reef, at one point of time, that would have been a fringing reef in all probability. The land in between them has sunk, creating a kind of a barrier-like feature. So these are basically situated away from the coast, and in between the coast and the reef, there is relatively wide and deep lagoon. The reef is called a barrier reef. Then further, even as this also subsides, then you are left with only those corals in existence. Look at this. This is where at one point the central land would have been in existence that has sunk. Look at the color of water all around. The dark blue to blackish water. This gives you an idea of the depth. So that tells you all around it, water is very, very deep. In the central portion, the water is shallow, and the water appears brightish white as well. Why do you think water appears brightish white? Why is the coloration of water appearing to be brightish white? Is the water very clean here? Is it that somebody has installed Kent RO water purifier here? That is why? Or is there any other factor? No. Due to the presence of calcium carbonate. Very good, guys. So due to the presence of calcium carbonate that you find in the case of these lagoons, that is why you have the whitish coloration. That is where, if you observe the waters in the region of Western Pacific, in many of these island areas, water will appear to be very crystal clear. It is not as if somebody is there deputed to clean water, and when you come to beaches in India like Puri, Goa, Chennai, etc., there is no one to clean the water. No. The base is made up of calcium carbonate, which reflects light. That is why it appears white. So next time when your friends post one of those pictures on Instagram or any of the social media handles, make sure you understand that it is not that because of some deficiency India has got dirtier waters. Wherever you see those cleaner water, in Lakshadweep, you will find a lot of these kind of instances. That is why in many of the recent essays which are being published, it is always touted that Lakshadweep is a kind of a case study of how it is a kind of a lost revenue stream for us, for tourism. Even though the ecosystem is very critical, but that also pitches in a case where we can utilize this pristine beauty for sustainable tourism. Because few hundred kilometers to the south of Lakshadweep, you have the island of Maldives, which every year ends up earning millions and billions of dollars in revenue due to tourism on the same group of islands. Why not Lakshadweep? If not billions of dollars, at least few $100,000. Imagine how the local population's life will simply upend itself. But there are other harmful impacts as well due to pollution, etc., which will happen due to construction, etc., which will happen. So you have to always present a balanced picture. And this is something which has been asked from many candidates in this year's interview process as well. Okay, so these are basically your atolls. These are the most common type of coral reefs and are roughly circular or horseshoe shape in the size and shape, with a steep outer slope. That is why you have deep waters and a shallower level in between. This is what is referred to as atoll. Okay. In many of the cases, from the evolution of the landmass to the formation of an atoll, it is a continuous process which spans across hundreds, thousands, and even millions of years. Observe that how initially, due to volcanic eruption, you have emergence of a new land. And that emergence of a new land, eventually it undergoes a pyrogenic force or a pyrogenic movement due to which it starts sinking. By that time, you have the growth of the fringing reef in this area. That fringing reef gets converted into a kind of a barrier reef system. And as the subsidence further continues, then you have the formation of what we refer to as an atoll. Okay? So that is how you have the formation. Now, corals, they are not only important in terms of biodiversity, they are also very relevant and very important in terms of how they influence the economic scenario and socio-economic condition. Because wherever you have corals, the fish population will be high. If the fish population is high, that means what? Fishing income will be there. Also, you have many hundreds and thousands of tourists who visit these areas to look at these corals. So tourism income will also be there. So across the world, overall, close to around 500 million people, or 50 crore people, they are directly or indirectly benefited from this coral reef. Now, it also replenishes the amount of dissolved oxygen which you find in the case of oceanic waters. And reefs, basically, they are also offering hope for creation of newer drugs to treat cancer, and they buffer shorelines from the effect of cyclones and storm surges and even hurricanes. What do we mean by that? So basically, if you consider a coastline, here let's say you have the growth of corals, right? And here you have the water on top. Now this water, when it comes in, the waves break here itself. So the coastline never experiences a storm surge or a very high wave generated. So that is also providing a kind of a natural protection to the coastline in these areas. Okay? So that is the aspect of corals, right? Now, after this, we take a look at a few of the previous year questions, at least the objective ones. And then after that, we will be coming to the portion of Indian geography. Okay? So we'll take a question at a few of the questions, at least the objective ones we'll take a look at. Consider the following statements. In the tropical zone, the western tropical zone within the tropics, the western section of the oceans are warmer than the eastern sections owing to the influence of trade winds. In the temperate zones, the westerlies make the eastern section of oceans warmer as compared to the western sections. Which of the above statements is or are correct? No, Abhishek, incorrect. You have committed a silly mistake, and this is why UPSC puts these questions. Good. Still, we have majority of us who have given the correct answer. So here, when we say western section of the oceans, we mean the eastern part of the continental area. So let's suppose you have two continental land masses, right? Now, let's say this is the tropics. So western section will experience what? The trade winds. Trade winds lead to what? Downwelling in this area. Downwelling. So as a result of which, the western section of the oceans are warmer, isn't it? Then in the temperate zone, the westerlies, they move in this direction. So they will cause downwelling here, right? So that is where the eastern sections of oceans are warmer in the temperate region. So both of the statements are correct. So the answer is both 1 and 2. Right? So most of you have would have committed mistake owing to the eastern and the western section of the continents. And that is precisely what UPSC is looking for. If you commit 2 or 3 such mistakes in a paper, that is virtually unforgivable because your competition will not, and that puts you out of the race in the prelims. So be very, very careful. The most important fishing grounds of the world are found in regions where warm and cold atmospheric currents meet, river drain out, large amount of fresh water in the sea, warm and cold oceanic currents meet, continental shelf is undulating. So I expect all of you to get this correct, guys. Very good. So here, warm and cold ocean currents wherever they meet, that is where you have ideal fishing grounds which are created. Tides occur in the ocean and seas due to which of the following factors? Gravitational force of the sun, gravitational force of the moon, centrifugal force of the earth. So which of these leads to the formation of tides? Shiva, but I hope the question was understood. I hope that you understood what the question was asking. Beautiful. Very good, guys. So gravitational force of the sun and the moon, as well as the centrifugal force of the earth, they generate tidal movements across the various different oceans. Then consider the following statements. Most of the world's coral reefs are in tropical waters. More than 1/3 of the world's coral reefs are located in the territories of Australia, Indonesia, and the Philippines. Coral reefs host far more animal phyla, that is, far more number of animal species than those hosted by tropical rainforest. Which of them are correct? Shamil, get these questions correct. That is all that UPSC asks out of you. Yes, there will be factual questions here and there, but those factual questions nobody gets correct, right? And individual candidates who get it correct by hook and crook, they will come out of the exam all that I knew this since I was born, etc. Don't get bothered by it. It is these questions which pull you in or put you out of the race. So if you are getting it correct, fair enough. Very good, guys. So here, most of you who have committed mistake, I have committed mistake in the third point. So the first point, most of the coral reefs are found in tropical waters. That is correct. More than 1/3 of the world's coral reefs are found in the region of Indonesia, Philippines, and Australia. That is also correct. Coral reefs host far more animal phyla than hosted by tropical rainforest. This is incorrect. If you consider just the number of insects that you have in these rainforests, they far outnumber the number of species hosted by the coral reefs. So just the insect population itself, that is humongous. So here third is incorrect. So you have 1 and 2. Okay. At one of the place in India, we have done this. At one of the place in India, if you stand on the seashore and watch the sea, you'll find that the sea water recedes from the shoreline a few kilometers and comes back to the shore twice a day. And you can actually walk on the sea floor when the water recedes. This unique phenomena is observed or is seen at Yes. Here again, I expect most of you to get it correct, guys. Yes, Shiva, that is correct. Yes, Shivam. This question was asked because it was in news that year because of various different missile tests which were happening around that area. So this, most of you have got it correct. It is C, Chandipur. Okay. So this is, yes, Vipin, this is a kind of a connotation of a current affairs type of question. Now, see, there is a larger perspective that and a larger conception in mind for most of the candidates that UPSC does not repeat the questions. Here I show you how UPSC repeats its question. This is a question which was asked in 2022, that is this year. Explain the factors responsible for the origin of ocean currents. How do they influence regional climate, fishing, and navigation? So here you have to talk about the factors influencing ocean current: heating, wind, Coriolis force, shape of the coastline, as well as you have the bottom relief features. Explain each one of them, give examples, and then write about how do they influence the regional climate. Colder current cools the area, warmer current warms the area. Then also they create deserts in the western margin. Then in the case of AMOC also we have seen that they end up exchanging heat, providing rainfall relief in that area, right? So all these factors, how fishing, when you have mixing of warm and cold ocean current, very ideal fishing grounds. Two examples: Labrador current mixing with Gulf Stream, Oyashio current mixing with Kuroshio. Both of these ideal fishing grounds. Then navigation, it allows for the movement of ships and further allows for the movement which is generated. So all those factors you can talk about. Then a question which UPSC asked 5 to 6 years earlier: what are the forces that influence ocean currents? Describe their role in fishing industry of the world. So the same question has been repeated. So that is a commonality in both geomorphology as well as in oceanography. You'll find that the type of questions which can be asked are absolutely limited. So the same type of questions are repeated again and again. A couple of more questions. Now, tropical cyclones are largely confined to South China Sea, Bay of Bengal, and Gulf of Mexico. Why? So you have multiple factors: closely surrounded by land, due to which temperature increases suddenly. You have downwelling which happens in these areas due to presence of the trade winds. Then you also have the conditions where influx of river water leads to ocean stratification, leading to concentrated heating, which can generate tropical cyclone. Elaborate on these areas. Okay, so in the case of Walker circulation also, normal Walker circulation will lead to formation of cyclonic circulation in South China Sea, Bay of Bengal area, right? Even in the case of negative IOD, both these areas will get warmed up. Neutral IOD also, both these areas get warmed up. So those factors you can always talk about. Then account for variation in oceanic salinity and discuss its multi-dimensional effects. Oceanic salinity, how it varies horizontally, vertically between different latitudes and across the depth. Why does it vary? Evaporation, precipitation, influx of river water, as well as melting and freezing of glaciers. Then halocline, the concept of it; stratification, the concept of it; thermohaline circulation, the concept of it; nutrient mixing, the concept of it for biodiversity, etc. All those factors you can write here. So that is what is to be written. Again, I will ask you the same basic question. How many of you felt comfortable while dealing with these questions, and how many of you felt absolutely uncomfortable? Both for 15 marks. Comfortable? Very good. So just look at these questions. These types of questions are asked in the basics. You have few of the factual questions which are derived from current affairs of that year. So please don't get demotivated by those factual questions here and there. Set yourself a target that out of the 15 to 16 questions which are asked, we will get around 10 to 12 of them correct. Never go into the exam hall with the ideology and the principle that because I am such a good guy or I am such a good girl and I have done all the good things in my life, I wake up early in the morning, I take care of the cattle and animal as well, and I have a good behavior. That is why I will get 100 out of 100 correct. We are no longer in class 2. We are appearing for the civil services examination. You are going to compete with one of the toughest and the most sharpened mind across the country. So please don't have that expectation that UPSC will roll out questions where you can get 100 out of 100 correct, right? So the ideal aim should be that in the first reading of the question paper for prelims, you should get 40 to 45 of those questions you should be able to attempt. Even the best of the candidates, they are able to attempt 40 to 45 questions in one go. After that, even in those 40 to 45 questions, you will commit 2 to 3 mistakes at the minimum. Okay? Have that reality in front of you. It is very important to see the reality. Anybody in the world who comes to you and tells you, or comes on YouTube and tells you, or comes on any social media platform and tells you that, look, the question paper was such, I could solve 85 questions easily. That person is lying. That person is absolutely lying. So never believe such individuals who tell you they can get your 80-85 questions correct, or individuals who say that they have done that many questions correct. In fact, there is that very infamous scenario where one of those individuals was caught cheating in the mains examination. If you remember, in Tamil Nadu, one of the individuals was caught cheating. And later on, UPSC revealed that UPSC could catch that individual cheating because there was a surveillance team which was put in place. And do you know why the surveillance team was put in place? Because that individual scored close to around 176 in the prelims. So imagine, even UPSC does not expect you to cross that much. If you somehow cross that much, that in itself will be an anomaly. And anyways, prelims marks are not counted. So in the first attempt, or in the first reading of the prelims paper, you should be able to gauge around 40 to 45. Next 20 questions you will be able to solve by your logical application. Application of your logic. That will take the figure closer to 70 to 75. After that, depending upon the and gauging upon the difficulty level of the question paper, you can attempt at least up till 85, you can go to 90, or you can restrict yourself to 75 to 80, depending upon how many negatives you have the tendency to create, how many negative marks. So set that aim. That is the real picture. That is what all the UPSC aspirants go through. Any of you, if you have that habit, or if you have that tendency that, but in school I scored 100 out of 100, here you are saying now I'm taking classes also and still you are saying I will not be able to score 100 out of 100. So sorry to break your dream, but this is what the civil services examination is all about. Okay. Having said that, now we come to the portion of Indian geography. Very brief introduction should I provide, or should we end the session here? Okay, fair enough. We'll do one thing. We'll cover it on Monday. Very briefly, I will provide you the introduction. This is the portion of geography due to which UPSC wants you to study the subject. Now we are coming to an area due to which the parameters of it, the entire aspect has been built up for this particular portion, Indian geography. UPSC wants you to understand it. UPSC wants you to excel in it. Because when you consider India, India is not merely a landmass. India is not merely the existence of a country. We are a civilization. We are a unique place which has got a living civilization more than 5,000 years old. From north to south, from east to west, if you venture out, variety of land conditions, variety of vegetation, variety of climatic patterns. While many of you in the northern part of the country are experiencing severe thunderstorms and rainfall right now, many different parts of the country, they are experiencing very hot conditions, due to which the food, the clothes, the language, the society, the tradition changes every few kilometers. There is no land or there is no region across the world which can encompass or which does have so much diversity contained in it. And for that, we need to understand India's geographical aspect. Here, we will be studying the portion of India's physiography, what makes this country so unique. We are going to study about India's forests, the soil, the river systems, and the agricultural setup, minerals which are present, and also some part about population. Now, what defines India is not merely its geographical extent. You have to understand that this is a region which is referred to as a subcontinent. Have you ever heard American subcontinent? No. Have you ever heard Mexican subcontinent? No. But you always hear about Indian subcontinent. This has not only provided itself as a cradle of the birth of civilization. We had the Indus Valley, the Harappan civilization. But along the way, this has served itself to be the melting pot of various different cultures, various different lifestyles and habits. From Indo-Greeks to Afghans to Central Asians to even East Asians, everyone came upon this land and found what they were looking for: ideal conditions for life. And that is where today's India, when it looks to the 21st century, it again looks at the same opportunity that it had thousands of years ago to shine across the global map. The location, the geostrategical location that India has, provides it with a kind of an unprecedented advantage which no other comparative country has. If you, let's say, get selected for this prestigious examination, you will be given or delegated a kind of a district. Now there, you will have to face the local realities. The crops are failing. The irrigation is not happening because the climate is failing. Why? Because of also local topography. So that is why UPSC wants you to understand climatology, geomorphology, oceanography, so that you can understand our country better. So from Monday, we'll initiate the discussion for Indian geography. So see you again on Monday. Till that point of time, take care of yourself, have a good weekend, and goodbye. So let's take a few questions till now. And how many questions we should try to attempt in mains? Monica, all the questions. Please understand, in mains, if you have attempted around 20, all the 20 out of 20 questions, you have already covered 90% of the task. Only 10% your quality will decide. Okay, leave all those advices that people are pouring out to you through the magazines, through the social media, YouTube, etc. That is why I oftentimes say that in the present day of information, there is overflooding of information which spoils the candidates. Invariably, you will find all the candidates, the toppers who have succeeded, all of them, they have that unique ability, and that is the ability to write 20 questions, still at the end of the day, find those 5-minute window in which they can complete a revision. If you are able to do that, that will come only after you have practiced close to around 1,000 to 2,000 answers you have written on your own, then you will have that ability. Okay? No negative marks in the mains. It is a subjective question. Subjective question, why there will be negative marks? Can we set a target of 120 marks as a reality? Pranay, absolutely yes. See, 120s is considered to be a safe bet. In fact, for the past 4 to 5 years, even 115 is considered a safe bet. But you never know about the vagaries of UPSC. So ideally, I would suggest to you, get a target of 120, and that will make you eligible for forest services as well. How many questions in prelims from this portion? From the portion of geography or oceanography? From the portion of geography, you have in prelims around 12 to 15 questions. Okay. And in mains, you have around 105 marks worth of questions. Devansh, how heat waves become persistent in Europe when disturbance in AMOC? Because now the Gulf Stream does not lose heat to the atmosphere, means no convective clouds getting created, means a complete lack of rainfall in that area. Vaibhav, it is up to you, my dear friend. I cannot advise you what you listen to or don't listen to. But one thing I would suggest, see, I have also I have had the good fortune of guiding many of the successful candidates. In all of them, I understood, or I could see a pattern that all of them had their own strategy. You will never hear a topper from a certain year say that I heard from the lessons of that topper, previous topper, and that is why I became a topper. No, they will have their own strategy. Understand what needs to be studied. Look at that. Why do we look at various different videos on YouTube, etc., and social media? If you ask yourself very carefully, you'll find the same answer. The answer is we are trying to find a shortcut. Unconsciously, so we are trying to find a shortcut that maybe this topper will tell us that without reading newspaper also you can succeed. Maybe this topper will tell us that even after studying for 30 days only you can succeed. That is why we keep on listening to multiple sources. Everybody says to work hard, work hard. One of them, if they say that, see, I studied only for 4 months, I succeeded. That is something which catches our attention. And for the rest of the year, we relax that 4 months, that person succeeded. You don't know what that person has studied in their graduation, how much they have studied previously. You don't know their mental capacity as well. So please don't get distracted by it. Look at the syllabus, look at the previous year question, look at the content in hand. The rest is up to you. Okay? And cutoff in prelims, Baldev, for general, roughly around 95 to 100 it is moving around, but 100 plus minus 5 is what you should consider. Rupal, for current affairs, from which year shall we start preparing? Immediately. But final consolidation for revision that you are doing, final 12 to 15 months, you should revise frequently, but current affairs, you should start reading immediately. What ranks requirement for IPS? Saini, get the best rank and select IPS. The interview board will also be very happy. If you give IPS as your first preference, they will grill you, but they will give you very good marks. One of such candidates, I'll not take the name. So that individual, he named IPS as his first choice of service out of 275, where the average marks in interview is around 172. That was a panel headed by the ex-commissioner of Delhi Police, that is B.S. Basi, and he got around 210 in interview. The second time he appeared because of some reasons again, and again he chose IPS, and this time again he got 206. So if you are very hell-bent, so why to think about? But generally you will see that if you have a rank within 200, so you get around 150, 180, in general, you will get IPS. And Arun, how can I improve writing skills? By practice. Write as much as you can. Physiographic portion, the weightage in prelims is maybe you can get one question, the locational aspect of that question. Gagan, speed is very slow in building answer before writing because of lack of practice. That is why I said write around 1,000 to 2,000 answers. Then you will gain that level of proficiency. Mathli, is notes mandatory? No. Note making is not mandatory, but note making facilitates your revision process. Where, let me paint you a scenario. Tomorrow you appear for your mains exam, let's say. In the morning half, you have GS paper 1. In the evening, you have GS paper 2. Next day, you have GS paper 3 and GS paper 4. So that means today you will have to revise history, art and culture, geography, society. Then you have to revise polity, governance, international relations. Then you have to revise environment ecology, economics, IR, science and tech. So will you be opening up the books and notes of all of this? So here you have the candidates who make very concise and short notes. They are able to revise within a couple of hours. Those are the candidates who are very high on confidence. And it is all a game of confidence. Mathly, double digit. Generally, yes, as has been pointed out. Generally, if you have a rank within, let's say, up till 50, 70, or even 85, 90, you get IAS. Leaderboard, please, Supriya. Okay, leaderboard, if I have to show you. Okay. Sini, I've already answered your question. Why this layer of calcium carbonate not dissolve in water? Because generally CaCO3 dissolve in water, because that oceanic water also has got CaCO3. So yes, there is some dissolving which happens, but you have sedimentation and sand and mud also which replaces it. So yes, there is chemical erosion, but at the same time you have a makeup of all that as well. Okay. So is it Siddhant, is there enough time to prepare if the target is... Absolutely yes, my dear friend. Absolutely yes. You have a lot of time. Think about a target of double digit rank, if nothing. Okay. Yes, Maithili, that is correct. Amit, whether satellite-based study is needed to study ocean currents? No. No. Right. Coastline is shallow in eastern coast of India, but presence of coral is more in the western coast. Why? Because the continental shelf is much wider in the western coast. So that is where we'll restrict the session here, guys. Any questions that remain unanswered, you have the SMEs who will get back to you. You can write to me as well. I will get back to you. And tomorrow, you will have the questions uploaded for the test. Do appear for the test. Even if you score 0, doesn't matter, as long as you learn from it and you improve. Try to write it. There will be improvement slowly and steadily, which will happen. We'll meet again on Monday. Take care of yourself. Goodbye and thank you.